There we go. We are now recording. Awesome. Okay. So first and foremost, does anybody have any problems seeing my screen, hearing me? Can you hear me okay? Everybody's good? Give me a thumbs up if you can. Let me see. I think Melissa's back on. We have one more message. Yes, Roberto, thank you very much, sir. We can hear you fine. That's great. Sorry, I have a little bit of, I'm getting over a cold from last week and oh God. Anyway, luckily it's virtual. So no problem. Okay, so everyone's here. So we've got about 56 that have logged on. We have about 160 registrants. So I guess they'll trickle in, but we'll get started slowly, and then the workshop is going to be at 11:30. So we got a little bit of time before everybody connects. So for all of you in Mexico and Costa Rica, I stopped sharing. No, it's sharing. Uh, what am I sharing? Am I sharing instructions for um, how to use Google Chrome for translated captions? Can someone just say yes or no? Oh, Ernest is logged. Is that what I'm sharing, Ernest? Yeah. Because I just want to make sure I've got all my screens open and everything here, and it's just it's a bit of a mess here. Yes. Okay. Excellent. So if you guys can give that a try, that would be fantastic. Has somebody successfully set that up on their computer? Can you let me know if that's working for them to get translated captions? Has anybody tried that? Just put it in the chat if you have. Has anybody tried that? I mean, it worked for me on my computer, but obviously it'd be good if it worked for somebody in Mexico or Costa Rica. There's a translated slide. Yeah. So has anybody successfully set up Google Chrome for this? No? Anyway, I'm going to assume that, those that want to can. And actually what I can do is I can put it in the chat for later, or I can post it a little bit later. All right. Participants, we're starting. I can see transcription. Oh, okay. That's great. Oh, you can see transcription, Roberto, but it's in English, correct? So the instructions I have on the screen now is, yeah, exactly. It's to permit you to get translated, yet it's in English, correct? That's right, Roberto. So the instructions on the screen would permit you to get translated captions. So if you open Zoom in your browser and then you go to the settings in your browser, you can ask for captions and then translated captions. And then you get an additional box at the bottom of your browser that's going to give you the translation of what's being said during the conference. So that is an option for you if you don't already have something that gives you a translation. Okay, so that's why I'm spending a little leaving this up here to give you guys time to do that. You may have to log out and log back in if you're already on there on your local Zoom app, right? Because it has to be done through the browser for you to get the translated captions. Okay, so you're welcome to give it a try, and if it does work, let me know. It worked for me anyway when I was playing around with it, so that would be great. Okay, so that's my participants. I am going to get started once I move everything around my screen. There we go. So that should be the title. I'm going to keep an eye on the chat as well over here. Okay, we are recording. I think we're good to go. I believe. One last little quick check. Here we go. The reason I'm also taking my time here is because this is a different version of the it's a webinar version of Zoom. I'm used to teaching through my standard Zoom, so things are in different spots and whatever. So I'm just trying to get a handle on that. Okay. Good. Okay. So you know what? I'm gonna ask Ernest to raise his hand if he can do that. And I just want to, oh, thank you. And that pops up. So Ernest, yeah. Okay, and then I can click allow to talk. Yeah, that's amazing. I'm actually going to promote you to a panelist, Ernest, because you are. So that's great. And Roberto as well. I'll make you a panelist. Any of my other panelists, please. There you go. As my panelists show up, I will plug you guys in. Is Nushin here yet? Let me see, because you guys can help me out. Nushin's not here yet. Okay. All right. I'm going to get started. Welcome to Impact Med 2025. As the title says, we are going to be talking about from image to impact, bridging AI, innovation, and global health equity. So a special welcome to our international partners, faculty, and students who are joining from the Universidad de Costa Rica, the Universidad de las Américas Puebla, and of course from our home base here at the University of Toronto. So we have about 160 registrants. I would say about half are from the University of Toronto, and the other half are from Mexico and Costa Rica, and actually a few other universities around the world, including India. We have a good mix of undergrad, grad students, residents, fellows from the Department of Medical Imaging, and also from the department, so the Institute of Medical Sciences, where medical science, sorry, for the graduate students. And now, basically, what we're talking about today is all about moving potential to practice when we're talking about AI. So that's what we're addressing today, and my slides aren't moving forward. Oh, there we go. Just a quick, intro. If you don't know me, I'm of course at the University of Toronto. I'm a data scientist. I'm in the Department of Medical Imaging, in the Institute of Medical Science, and in the Department of Statistical Sciences. That's where I work. I'm also a faculty affiliate for the Schwartz Reitzman Institute of Technology and Society, which is the application of technology and these days AI in society. And I'm also a faculty fellow of the Community Engaged Learning, which is a lot of fun that we're having in our courses, which we leverage working with community partners for education and research. All right. So today our theme is from vision to impact. And the vision part is what we see in journals, in labs, and what we're doing. And these are incredible new algorithms, new models, exciting potential in AI. And that's the image part of our title. But the impact is the hard part. It's the real world deployment, right? The patient at the bedside, the clinician in a rural setting. And today, we are focusing on that pathway, the bridge from that vision to real, lasting, and equitable impact. That's what we're talking about today. Now, this theme is deeply personal to me, and it's the core thought I want to share to open this conference. And so, from my work building offline capable AI tools with partners in places like Costa Rica, actually in India as well, I've learned that the single biggest challenge isn't actually the algorithm. That's actually the fun part, right? The modeling is the fun part. That's only the start, right? The real barrier is the lack of sustainable ecosystem for, crucially, validation, for maintenance, and also for the true local ownership. And so how do we build that? And that's the central question for us to explore today. And we're going to have the opportunity to meet many people that are going to talk about that today. And, no surprise, we can't build this ecosystem alone, right? And this conference is a perfect example of what I call the global classroom. And actually, at the University of Toronto, there's a program called the Global Classroom, which both universities are part of. The UCR and UD Lab. And that's a collaboration which is essential for this work. And of course, I want to extend a huge thank you to our partners who have made this possible, which is the IMS, of course, the Department of Medical Imaging, and our colleagues, the UCR, the UD Lab. And this collaboration is the foundation of everything we're doing here. And this is our second conference. We did our first Impact Med conference last year, and this is our second one. So we do have a fantastic day planned to tackle this challenge from all angles. So we're going to start with the practical, which is our hands-on MedGemma workshop. And so we're going to have Ernest and Nushin, walk you through some use of MedGemma, so the foundation model application. And we're going to have an expert, Anastasia, who is going to be our radiologist expert, who is going to contribute as well to this workshop. And this is, the code will be provided. You can, use the code. You can, I don't think you'll have time to actually run the code at the same time as the workshop, but, Ernest will step you through that. Who knows, maybe you'll be able to pick it up really quick. And that's going to be the fun part of our workshop. And then after that, we will get, a great high-level strategy from our keynote, Dr. Narinder Paul, who is the chief chair of radiology at Western University in London, Ontario, Canada. And he will be talking about the entire AI continuum of care. This afternoon, I'll be moderating a panel of international experts to debate the very challenges of global deployment. So that will be great. We'll have some nice interaction between, basically the three universities. And throughout the day, we'll have some opportunity for forums for you to connect with each other. And I hope that you'll take this time to build some new collaborations. Okay. Okay, so this is just to give you a little teaser on the workshop. Right after these remarks, we're going to go into the hands-on workshop. And this will be your chance to move from theory to practice. And as I said, Ernest and Nushin will guide you through preparing a data set, applying a foundation model, MedGemma, and most importantly, evaluating the results of a classifier that you build. Okay, so that's the plan for the workshop. And then this afternoon, please come back because there'll be a little bit of a break for you, obviously. Please come back for the keynote address from Narinder Paul. And then what he will be addressing is AI across the continuum of care. And that's where, we'll be looking at the critical roadmap and how these tools are created, tested, and ethically implemented in order to transform the patient experience. So that's the key, is thinking about the patient experience. And then the panel, we'll wrap up the panel, Medical Imaging for All. And this is where we'll dig into some of the hard questions about global deployment, low-cost innovation, and building those sustainable ecosystems that we just talked about, right? And I'm looking forward to a lively debate with our panel experts. And hopefully by then, well, not hopefully by then, but we'll have the opportunity, you will have the opportunity to ask questions and either in the chat or, unmuting yourself and speaking, okay? So once again, thank you for being here and sharing your energy and your expertise. My request to all of you today is to try and engage as much as you can. Please ask hard questions. We're ready. And try and connect with someone new. That'd be kind of fun. And hopefully this will build that bridge from vision to impact, or at least give you some ideas of how to build that bridge. And so on that note, please enjoy the conference. Now, just a few housekeeping things. So this year we are issuing certificates for this of completion, I guess, of this conference. But you do need to attend the majority of the conference. So let's say workshop and keynote, or keynote and panel, in order for you to receive their certificate. If you just log on for 5 minutes and log off, clearly that's not going to cut it for the conference certificate. Other than that, if you have any problems understanding, or if you'd like me to do something different in the delivery, so meaning through the chat or through how we're showing or sharing, that would help you improve your experience, please let me know. So you can either send me an email or you can put it right here in the chat and say just to me. That would be great. Okay. And I'm happy to accommodate. All right. Excellent. So let me just take a minute to see if my panelists are here. And I'm going to make them. Nushin hasn't joined yet, I guess. But Ernest is here, right, Ernest? Oh, Jean, there he is. Jean. I'm going to make him a panelist. There we go. So Giancarlo should be a panelist now. Okay, I don't think I missed anybody else. Okay. First and foremost, Nushin is here. Huh. How did I miss you in the list? Sorry, Nushin. Okay. That's funny. Okay, I will. How did I miss Nushin? Give me 2 secs, guys, because she is important. She is doing your. That's funny. I didn't see you there. Okay. There you go. Excellent. So we have Ernest and Nushin and Anastasia. She joined. Anastasia. There she is. Fantastic. Promoted to panelist. There you go. Maybe it takes time to come over. There we go. Excellent. Excellent. Okay. So on that note, let's step into the workshop. So I'm going to stop sharing. And then I'm going to ask, I think it's Nushin who's first. I'll ask Nushin to share. Oh, there's Anastasia. There we go. So I don't think, Melissa, I don't think she's logged on. So I'm guessing there's not a way. I believe the type of Zoom meeting selected for the webinar doesn't allow it. Yeah, that's correct. Yeah, that's right. We can't unmute. Yeah, unfortunately. So the muting, you have to put your hand up, and I can let you unmute. Question here. Is it okay if we leave and rejoin the conference? Absolutely. That's fine. Not a problem. And I will just, yes, of course, that's fine. Okay. So my guess, Melissa did she send me a message? Sorry, guys. I'm just multitasking with so many windows open, but I don't think, unfortunately, there's a way to let you guys rename. So it's just going to be when you logged in, I think it said, are you okay with this name or something like that? And that's what you end up having. So if you can, when you log in, just put your country. That'd be great. Anastasia, can you speak? I think
yes. Good morning, everyone.
Perfect.
Ernest wants to become a panelist. Have you made him a panelist?
I thought I had. I will do that right now. Let me check. Thank you. Oh yeah, Ernest. Yeah. That's funny. I thought I had and it didn't go through. Oh, there we go. There we go. Sorry, Ernest. My apologies. Okay. Now are we good?
No problem. Thank you. One note, I think
Yes.
if everybody uses the link that was sent to them after the registration, then the names will be okay.
Oh,
So the
all right.
links are unique to each individual.
Oh, wow. Okay. So you have to reuse your link. Okay. Thank you for that. So if you log off and come back on, you have to make sure you reuse your link. Is that right? Okay. Okay. Wow. Thank you. Thank you. That's good to know. That's good to know. So please reuse your link. And when you log in, maybe you can change your name at that point. Is that right, Ernest?
Well, when you re-log in, based on the names that you registered with,
Yep.
your name will be set.
Oh, okay. I got you. I got you.
There's no option for setting
Yeah,
your
okay.
own.
It's not a big deal. I just thought it was nice, for the panelists to be able to see where people were from. We can kind of see it from the names anyway, but it is what it is. We'll know for next time. So, it's just every version of the webinar and whatever, depending on your account, is a little bit different. So, but we'll know for next time. Ernest and Nushin and Anastasia, but I think Nushin is starting. Take it away. Let's do the workshop. So I think, yes, Nushin has shared her screen. Excellent. Thank you.
Hello everyone and welcome. Our presentation today is titled The New Stethoscope, LLMs, Multimodal Models, and the Future of Clinical AI. We chose this title very intentionally, much like the original stethoscope. We believe AI is not a tool to replace clinicians, but an essential instrument to augment their senses, helping them see patterns and gain insights they couldn't before. My name is Nushin Jafarpishe, a postdoc at the University of Toronto. I hold a PhD in electrical and computer engineering from Concordia University. My background involves applying AI to health-related problems. We also have Ernest, a postdoc researcher. He holds a PhD in medical science, is an NVIDIA healthcare ambassador, and an instructor with the NVIDIA Deep Learning Institute. He brings a focus on translating AI to practical clinical applications. And we are honored to have Dr. Anastasia Economou, a professor of radiology at the University of Toronto and the division head of cardiothoracic imaging at Sunnybrook. She's a staff radiologist and an affiliated scientist whose research focused on using AI to classify and understand lung disease. In this workshop, first I'll cover the theoretical and preliminary concepts in LLMs. Then I hand it over to Ernest for the coding section and Dr. Anastasia for interpretation and discussion of the AI results. So let's start with the basics. What are large language models? You've all heard of tools like ChatGPT. At their core, LLMs are AI systems trained on vast amount of text data with one primary goal: to understand and generate human language. They're built on a groundbreaking architecture called the transformer. The key innovation here is self-attention, a mechanism that lets the model understand context by weighing the importance of different words in a sentence. It enables LLMs to learn long-range dependencies and contextual meaning by allowing each word in a sequence to look at and weigh the importance of every other word. The way they learn in simple terms is by predicting the next word. By doing this billions and billions of times, they do not just memorize text, they learn the underlying statistical patterns, grammar, and even complex concepts. Large language models functions through a complex and systematic process. LLMs are like digital chefs. Think of it this way. Your prompt, the words you type in, are the ingredients. The model chops these words into smaller pieces called tokens. It then mixes them using its knowledge of attention and context and serves up a perfectly seasoned new sentence. It's a process of deconstruction, understanding relationships, and intelligent reconstruction. So why is this matter for medicine? Because medicine is incredibly language heavy. Think about it. Patient histories, clinical notes, radiology reports, research papers, insurance guidelines, it's all unstructured text. This is where LLMs show their revolutionary potential. They can summarize patient reports. A doctor could get a concise summary of a 200-page patient file in seconds. Another, it generates structured reports. They can listen to a doctor's free text dictation and turn it into a perfectly formatted structured report. Explain findings to patients. They can take a complex medical report and translate it into plain, easy to understand language for a patient. So LLMs can turn massive amount of unstructured medical data into usable, actionable insight. Building on that, we can see the applications of LLMs span across the entire medical field, which can group into three main pillars: clinical practice, medical education, and medical research. In clinical practice, this goes beyond the report summarization we just talked about. We are seeing tools for medical question answering, handling time-consuming administrative tasks to reduce burnout, and even providing data-driven support for clinical decision-making. In medical education, the potential is transformative. LLMs can create personalized learning paths for students, generate new educational materials and case studies, and even simulate virtual patients for students to practice their diagnostic skills. And finally, in medical research, these tools are accelerating discovery. They can provide assistance with academic writing, help researchers by translating studies from other language, and perform complex data analysis on large data sets. And that evolution involves a specific life cycle. We can't just take a general model like ChatGPT and drop it into a hospital. It needs to be specialized. This happens in three phases. First is training. This is learning from scratch on general data from the entire internet. Fine-tuning. This is where it becomes a specialist. We take the general model and retrain it specifically on medical textbook, clinical notes, and research papers. Inference. This is the applying knowledge phase, where the fine-tuned model can now answer new unanswered medical questions, a process that is called zero-shot or few-shot inference. Let's consider your thinking process. When you are presented with a picture by someone who is telling you about something, you don't simply read what they are saying or simply observe the picture. Your brain skillfully integrates the two inputs to form an understanding. This is exactly what multimodal LLMs do. They are capable of processing multiple data types at once. They aim to mimic how humans combine multiple information sources for reasoning. Multimodal LLMs integrate text, images, audio, video, but traditional LLMs process only text. Also, the application of LLMs we talked about so far in medicine are all powerful, but they are still primarily text-based. To become true clinical specialists and handle the full spectrum of medical data, we need multimodal LLMs. A clinician uses all their senses. They look at the patient, they listen, they read the chart, they see the X-ray. So multimodal LLMs unlock the revolutionary power of AI that can see, hear, and speak. We are moving from AI that only reads text to AI that can perceive and understand different types of data all at once. This is in practice today. These models are being built to integrate and reason about image, text, and other data sources, just like a clinical team does. Multimodal LLMs do not simply load various AI systems on top of each other. They involve complex encoding, alignment, and fusion algorithms. First, in the encoding phase, the model has to perceive the different inputs. It uses one specialized component, like an image encoder, to turn the X-ray into a set of numbers. It uses another component, let's say a text encoder, to turn the patient notes into another set of numbers. Second, which is the core challenge, is the alignment phase. The AI must learn how the numbers representing the image relate to the numbers representing the text. It has to learn that this specific cluster of pixels in the X-ray correspond to the word pneumonia or fracture in the report. Third, in the fusion phase, the model combines or fuses those two aligned streams of information. This includes one single rich data representation that contains both the visual and textual context. And finally, in the processing phase, this single fused input is fed into the large language model, which can now reason across the combined data to answer a complex question or generate a new comprehensive report. So, when we apply multimodal LLMs in healthcare, we are talking about an AI that can look at a chest X-ray, read the radiologist notes, and review the patient's EMR data, all at the same time. However, we must be critical and reasonable. This technology introduces significant challenges. First, privacy and regulation. How do we train models on sensitive patient data while remaining fully compliant with privacy laws? Second, transparency and fairness. We must ensure these models aren't black boxes and that they don't amplify existing bias in our health data. Third is complex integration. How do you actually combine a high-resolution image with a dense text report? It's a massive engineering challenge. And finally, and most importantly, we need clinical validation. We cannot deploy these tools until we have proven in clinical trials that they are safe, accurate, and truly beneficial. Let's look at a concrete case study that tackled these challenges, MedGemma. This is a perfect example of a multimodal medical model. If you look at this timeline, you can see the rapid progress. In early 2025, Google released the general-purpose open-source Gemma models. These models provided the architecture foundation for MedGemma. They were built on research from the Gemini models. In May, MedGemma was officially announced and first released at the Google I/O event. The initial release included MedGemma 4B and MedGemma 27B text only. MedGemma 4B is a 4 billion parameter multimodal model capable of processing image like X-ray and dermatology photos and text. MedGemma 27B text only is a 27 billion parameter model optimized exclusively for medical text comprehension and clinical reasoning tasks. In July 7, the initial MedGemma technical report was submitted to arXiv. The report detailed the model's architecture, training, and performance benchmarks. In July 9, Google released the flagship MedGemma 27B multimodal instruction-tuned model, completing the initial collection. This version integrates image, text, and electronic health record data capabilities, offering the most comprehensive feature set in the family. Let's look at some key features of MedGemma. Medical image analysis. MedGemma 4B can interpret medical scans like X-ray, MRIs, and CT images. It helps radiologists generate detailed reports and identify key findings. Text summarization. MedGemma 27B can take long clinical documents and turn them into concise, easy-to-read summarizes. This saves time for doctors who need quick information. Medical question answering. Both versions can answer questions like what are the symptoms of heart failure or how is asthma treated? This helps doctors, students, and even patients. Open source and flexible. Being open source means you can fine-tune MedGamma with your own medical data to make it even more accurate for specific needs. MedGamma has many potential uses in healthcare. Here are some ways it can help. Radiology reports. MedGamma 4B can generate detailed reports from medical imaging, helping radiologists save time and focus on critical cases. Clinical summaries. MedGamma 27B can process long patient records and create summaries, making it easier for doctors to get key information fast. Medical education. MedGamma's question answering features make it a helpful tool for teaching students and training new healthcare professionals. Healthcare apps. Developers can build apps that integrate MedGamma's features supporting telehealth, patient monitoring, and decision support systems. This brings us back to our challenge of clinical validation. We need a grand truth. For this workshop, we used an example from this reference dataset, book Interpreting Chest X-ray illustrated with 100 cases. In addition to this book, we also have a set of X-ray provided by Dr. Anastasia. As the slide says, this book contains 100 real clinical cases with questions, the chest X-rays, and most importantly, the expert radiologic impressions. We then use this expert explanation as our gold standard reference. We fed the X-ray and the question to MedGamma, and we evaluate its X-ray output for accuracy and completeness against the book's answer. This allows us to systematically compare the model's interpretation with the expert findings to determine its clinical correctness and, just as importantly, find its weakness and areas for improvement supported by also clinical knowledge of Dr. Anastasia. So we have covered the full journey. We started with the basics of LLMs and their broad application in medicine. We saw how they are evolving into powerful multimodal models that can see and read. And we've just walked through a real-world case study, MedGamma, and shown a concrete method for how we are working to validate it. Now that you have the theory, it's time for practice. I'll now hand it over to Ernest, who will walk you through the coding part, and Dr. Anastasia for interpretation and discussion of the AI results. But before we move forward, we have, I think, about 5 minutes for Q&A. So I'll be happy to take any questions. Thank you.
Thank you, Nujeen. Does anybody have any questions before? Oh, Jeff has a question. Please go ahead. Can you unmute yourself, Jeff?
So I can unmute
Oh,
it.
yeah. There you are.
I'm even going to turn on my camera for a second.
Yes.
That was a great talk. Thank you very much for that. And I actually didn't know that MedGamma 27B is available. So my question is, for those of us who don't have good hardware to run it on, do you know if it's hosted somewhere in the cloud if you want to do experimentation with it?
Yeah, so MedGamma parts, Ernest will talk about it more later. But actually, what we can certainly know that the archive from the MedGamma that contains like the how about training and this stuff are available, but in order to get the weights and exactly what they have done, it needs some some permission and ethical exchange and this stuff. So we cannot say it's fully publicly available and open source in that means, but it's possible to get the weights by some like institutional agreements.
Okay, thank you.
I can make some more comments on this. So of course there are some agreements. It's not hard to do. Google is doing a great job with open sourcing their models. The consideration for computational resources is not unique to anyone. There has been a lot of discussion in the research community, as you know. So there are many, many different ways. There are companies that give you resources on demand. For example, Lambda is one of them. So you can rent some online GPUs, even Google Colab. We're gonna use it today. I'm gonna go for the 4B model, but with a premium edition of Google Colab, you can even run the models there. Another way that if you have a, I wouldn't say high-end GPU these days, but with a decent GPU, another option you have to run the models locally is that you can go for quantization. So they cut off some of the precisions in the weights of the models, and in that case, the models become lightweight, and then you can run them locally. Given all the concerns we have in Canada and healthcare for patient privacy, this is another option.
Yeah, thanks. My hardware, so I can run a 4 billion parameter model, no problem. But even with quantization, I'm still too poor to have hardware good enough to run a quantized 27B model. So, but that's really, I appreciate that. I'm going to see if I can find it hosted somewhere or somewhere that I can download the weights to, like Lambda or even GCP maybe.
Sure.
Thank you.
All right, we have a question in the chat, and it's from Mabiha, if I'm pronouncing your name properly, I hope. Hi, I'm an undergraduate student at the University of Toronto. I was wondering if MedGemma moved to the clinical trial stage yet, or when do we expect to see it in that stage if it is not there already? Who would
Yeah,
like to
so
tackle that one?
So Ernest, correct me if I'm wrong, but I think it needs more clinical validation to become fully adapted to clinical to the real world, because as we see in the next part, we can see that maybe there are some differences between what the model says and what's the actually what's a real radiologist can actually comment on that. So it needs actually, I think, more time, because it hasn't passed many times that it has just released. So for sure, it needs more clinical validation.
Yeah, and I think we can have a great discussion on this at the end with Dr. Oikonomou's insight, because this is an open question. Of course, there have been many papers published with MedGemma, even though it's relatively new. But clinical trial, I haven't heard anything. Another big question is how to use these models eventually in clinical settings, because what computer scientists expect and design the models with those expectations can be different from what we need in the clinical setting.
So I can jump in as well. Just it's a great question, by the way. Thank you. Just for clarification, the MedGemma is the open model, and the reason they release it is because they want to accelerate innovation. So meaning, all of you after this wonderful workshop will want to play with MedGemma. But the model, it's based on a research model called MedGemini. No surprise. And that's the research model that's locked down and is not available openly. So if the model were to ever go to clinical trial, it would be the MedGemini model that would go to it. It wouldn't be the open source model. And then it would go through clinical trial, and then it would be released, as a product, essentially. So to answer your question directly, no, I don't believe it has. Are they currently in the process of trying to get it to go through regulatory processes? Maybe, but I would guess it's still pretty early. So to my knowledge, no. And don't expect MedGemma to ever become or go through that process. It will be MedGemini or a version of MedGemini that will progress from a research model, which is what MedGemini is, to a clinical model, like a clinical application product model that would go and be locked down for production and release through regulatory, right? So don't forget, all models, if they're released, have to be locked down. So meaning no change anymore until a new version that has to be assessed and validated before release again. Okay. Hopefully that answered your question. Any other questions before we move on to the fun of the workshop? Great. Let's get going because we're actually a little bit behind. So
Awesome.
take it away, Ernest. Thank you very much.
Great. So I put the link in the chat. We have a GitHub repository for this workshop. On the repo, you already have access to the codes, data, presentation, and also the results. If you go into the codes, we have only one long Jupyter Notebook file. For the data, we will have two cohorts of patients. We have DICOM files from 4 different patients, kindly shared by Dr. Oikonomo, and then we have some patients in the format of JPEG, and these are from the book that Nushin mentioned. To run the model, I could use my own resources, but I thought putting it on Google Colab would make it even better for you because you can just replicate what we're doing here. So same directory structures there. I'm gonna open the Jupyter Notebook we have, and then let's get started. All right, so the first step in developing any AI pipeline is designing a well-structured file and directory organization. There are multiple valid approaches, and none of them is universally the best. What really matters is to maintain consistency. So pay attention to all the details in your projects. And if you're advanced, you already know all these things. This part is just for those who are not that much advanced in programming and AI research. So file names, folder names, formats, every single detail matters. Even if you use dash or underscore or spaces. So first, we just mount the Google Drive, and then we change the directory to our code directory. So this one. So now our working directory is here. And then we just walk over the contents to ensure that we have access to all the files and etc. So the root directory is this one, ImpactMed 2025. And then we have the structures of the files that we just saw through the web interface. Okay, so if you look at what we have here for two of the patients from the DICOM repository, we have two DICOM files. And for another two, we have only one DICOM file. So that's an example of inconsistency. And then in terms of designing the pipeline, we need to take into account all these small things. So if you want to just use MedGemma or any other multimodal model for getting inference on specific cases, in terms of the research design, when you want to publish a paper, it will be a case report. So in that case, you're fine because it's just a case report. Who cares? You get two different inferences. You can even manually change the file names. and report your cases. However, if you want to go for like 400 patients, this becomes tedious and even impossible. So in that case, you need to have absolutely perfect consistency. So if you look at the JPEG repository here, for each patient, we have exactly 4 files. The names are exactly the same. So we have something which is called img.jpg. That's the main image file. And then there is question.txt and impression.txt. Impression comes from the radiologist. So it's kind of like a ground truth. Question is what we are asking from the model. And then we have a support image that at least initially you don't need to use it. However, later you can have more advanced pipelines. So that's what we have. A couple of other things. You can just use your API keys because for this workshop, we are pulling the model through Hugging Face. That's another platform that hosts open models, including MedGemma. And you can put your plain passwords there. It's less secure, especially if you're gonna share your codes. So what you can do is that on the left, if you see there is a secrets tab, and if you open the secrets tab, you can choose a name. I'm using HF token, which just stands for Hugging Face token, and then put the value. And in this regard, everything is much more secure. And in this cell, we are trying to just approve that we do have access to the Hugging Face. Now, there is another technical note about the family of MedGenoma model. Nushin briefly covered it. So we have 4 billion parameter and 27 billion parameters model. There is MedSiglib that's specifically trained for image classification. That's a bit different. But within the groups of 4B and 27B, based on the file names, you see PT, which stands for pre-trained, and also IT, which is fine-tuned after pre-training for instruction-based interactions. So if you want to do some sort of question answering, the IT model is going to work better for you. The one that has text, which is only one from the 27B group, that's a uni model. That's just as an input, it accepts text, and as an output, it gives you text. Last thing, through notebook settings. So if you go to edit, and then if you go to notebook settings, you can access some levels of GPU. So if you go on CPU, the models would still work. It will take much longer for you to run the models. With T4, which comes for free, you get access to basic stuffs, and that's what we have for this workshop. You can also pay, and then these other options get all unlocked, and then you have a higher bandwidth for your models, and also you're not that limited in terms of time. Okay, some notes I left on the notebook for you to review later. I'm going a bit faster because I want to have more time for the clinical discussion and also Q&A. Also, if we have advanced programmers, I don't want to make it that boring for them. At the same time, I want to cover the basics for those who do not have enough experience. Okay, so another thing is that you need to get access to the secrets, to the passwords that you save. So using the OS package and then setting environment variables, you can do that. And then we check if the code is running on Google Colab or else. Well, the else I'm just passing. However, if you want to run these codes on your local machines, that's where you need to put some checkpoints and print statements. We need a couple of libraries that are not installed by default on Google Colab. For those who are already familiar with the idea of Jupyter Notebooks and especially Google Colab, you know that if you put exclamation mark at the beginning of something, you get access to the shell of Google Colab, and that's how you can install different libraries that you need. Transformers is one of the most important ones, Accelerate, etc., etc. So you install all these things, and then we start just loading the models. Okay. So nice thing about Google Colab and Jupyter Notebooks is that it gives you some minimal versions of widgets built into the notebook. So if you look at the codes on the left and look at the options I have here, if I go for BPT, this model choice automatically is changed. Now you can do it using the codes. Of course, you can put the text here, or you can just select the model using this widget. Now, as I said, our focus is going to be on 4B version and then the interactive. Okay, so we have the model, and the rest is just loading the model. From Transformers, which is a very famous library backed by Hugging Face, you import the pipeline. And now we are building the pipeline through calling the correct model ID and then the needed arguments that we just defined. So if you do that, if you run this, I'm not running any codes here. I've done that before, and you already see the outputs here after the code cells, because I wanted to save time. But if you do that, depending on the bandwidth of your internet system, that temporal load of the servers, etc., it takes some time. But essentially, at this point, everything you need is going to be downloaded from Hugging Face to your Google Colab. And if you do it, you will see that there will be another folder added here. That's the way we wrote the codes. And it puts the checkpoints for the models, the train weights, etc., etc. So this is where we load the model. The model is loaded, and now we need to load our data. First, we work with the DICOM files. PyDICOM is a famous library for working with DICOM files in Python. So first, you need to install it. Again, exclamation mark pip, the standard package installer for Python, install, and then PyDICOM. You install it. Now I'm defining the model names manually because, as you saw, it was not consistent. For some patients, we had two. For other two, we had just one DICOM file. If it was consistent, or even if it is not, you can come up with some ideas. You can say, hey, just iterate over every single patient directory, and one by one, load every single DICOM file I have. So that would be a workaround. Anyways, so here I'm hard coding all the file names, DICOM file names. And so now we have access to all these in the form of PyDICOM objects. So ID4 slash underscore image1 is a PyDICOM object from that specific DICOM file for that patient. Now we need to start the analysis. For that, we need some helper functions. So the first one, I call it analyze DICOM with MedGemma. Okay, so we're gonna pass our DICOM objects, which are gonna be these guys, ID2 image 1, ID3 image 1 or image 2, etc. The pipeline, and then some other controls that we will discuss later. So when you do this, depends on your preferences and the design of your pipeline. What we suggest is that always try to get some visuals. Just visually check what is going on with the images, ensure that the file was read correctly, and you need to use all these controls as manual checks. Then we get the image, and when I say we get the image, we have the PyDICOM object. It includes DICOM tags as well as the image array. So with in this line, we get the image array and put it into image. Then we have something called prompt. If you have a little bit of knowledge about large language models, and if you have worked with ChatGPT a bit advanced, you've for sure heard this term prompt. Think about it as a text that you give to the large language model or your multimodal model. So it is very important to format this direction correctly, and itself can be a full day workshop. There is prompt engineering techniques, a lot of them. Rule of thumb, if you can somehow direct the models in a logical way, there's a technique called chain of thought, for example. If you can direct the models using those logical structures, you get better outputs. Now, this logic can be formed based on the clinical expertise. So if you are a radiologist, for sure the prompt you can write will be better than the one that I would write. Because you have the domain knowledge and you can provide better information to these LLMs. The only thing you need to know is that these LLMs or multimodal models are a bit different from us. So try to break down the process for them and guide them somehow in a logical way. Another thing which is very effective is that if you can give them some examples. With multimodal, it's a bit more challenging. With limited size datasets, it's a bit more challenging. But we do that with ChatGPT. Even if you don't know the term, you do one-shot or few-shot prompting, which means you ask your question and then you say, for example, this is one desired output that I would get. So that, for example, helps a lot. Then you have another part of payload for your prompt. So messages, some of these models need to know some roles. Some they don't need to know the roles. You don't have to describe a scenario that, hey, you are a board certified radiologist. For some models, you do not need to do that. For some, you have to, but it is always a good idea to include all these details because it helps the model to get started and be more direct to the point. And then we have the content. So we have the image, which was loaded, and then we also have the text, so the prompt. Okay, so that's what we are feeding into the model. And the rest is just calling the pipeline, the whole pipeline, using the message, using the image. And then there are some controls. This is another thing that depends on some decisive factors yet that are out of your control or not directly under your control. For example, this number of tokens. It means how many, for example, if this is just a unimodal model and this is just text only input, how many words? Well, technically it's a bit different, but roughly, how many words are you gonna input to your model? And it depends on the amount of computational resource which is available to you. If you have a small model, but if you use a very large and heavy input to the model, you get hardware failure or memory errors. So you need to play around with these hyperparameters and settings, but that's the idea. And lastly, you get the output in this out, and you format it to a parsable text, and you return it. So this text is something that comes out of your function, and as the input, you saw what we did. We just input the DICOM object. That's not the only part of the input. We also have the prompt, but this prompt in this design, I'm assuming the prompt is always the same. Again, use your imagination. It's not hard to imagine that there are cases that you want to have per case prompt. So a prompt, the directions that I would want to give for one patient is going to be different from the other one. In that case, instead of hard coding the prompt here, you could load this from a text file somewhere, and that text file could be in one of the patient directories. The rest is just formatting the output to get a better structured output from the model. You will see what we mean. Okay, done with the technical part for at least the DICOM repository. Let me just go through what we have for the first case. So ID1, chest X-ray 1. I'm just calling the function we went over, and I'm storing the output of the model into this case report variable. Okay, so this is the chest X-ray we have, and we get the output as part of the analyzing function, because we are printing the text here. However, you saw that we wrote another function to format this. So initial output is this. It's a bit hard to follow. Now, to get it better, we formatted using format case report, and now this is what we get. It's the time for me to stop and ask Dr. Anastasia to jump in and comment on some of the outputs that we got for this specific patient.
Yeah, Ernest, this is only the lateral of the case. There is also a
Yes.
frontal one.
Yes, so
Do we see them separately, or?
we see them separately. So for this lateral, we get one output, and then for the other view, we get another output.
So is there a possibility that we get a combined output, because this belongs to one patient?
Exactly. This is a fantastic point. It depends on the design. With this design, we have two separate reports. Now, there would be different ways. One way would be to input both images at the same time if the model supports, if the memory supports all those things. The other way would be to get these two reports and then give to a text-only model and say, hey, merge these two. Now, if you prefer, we can go to one of the cases that have only one view and then see what we have there.
No, it's like whatever you want. It's just that for a radiologist, for example, to assess the case which has a frontal and a lateral and understand what's going on, has more information, and it's probably unfair for the model to give them only one view at a time and expect to have the same critical thinking that the radiologist would have by seeing both at the same time. Like, it is as if you hide some information from me that I'm a radiologist. There are many cases in real life that we have only a frontal. Almost never do we have only a lateral. The lateral is an addition to the frontal. And when we have two views, frontal and lateral, we're always happier because we have more information. But when we don't have the lateral, it's okay, that's life. That's what we have. Lateral only is almost never happening.
Mhm.
Yeah,
Great
so
points.
whatever you want.
So, would you like to go over the second case? We have only the frontal view.
Okay, sure.
So, this is the chest X-ray we have, and then you can read the report here.
So it says lungs and pleura. The lungs appear clear without evidence of consolidation, edema, effusion, or pneumothorax. Cardiomediastinal, the heart size is within normal limits. The mediastinal is unremarkable. Bones, soft tissues, no acute fractures are identified. There are no lines. Normal chest radiograph, no acute cardiopulmonary pathology is evident. Yes, I totally agree. When I see this frontal chest X-ray only, I would consider it completely normal. I see the heart silhouette very good on the right side. On the left side, I see the pulmonary hyla. I don't see any consolidation or masses in the lung parenchyma on the right or the left side. The pleural spaces are very clear, very acute costophrenic angles. I don't see any lucency for pneumothorax. The osseous lesions are radiographically completely normal. The upper abdomen is completely normal. The gastric bubble is where it should be, no free air. So I would definitely consider this a normal. So it's completely correct.
Okay. Is there anything that you would say you would add to this report? Is there any part that the model is not doing an excellent job?
No, I think maybe I would not even include the lines and devices. Like, I would only include a comment if there is one. If there is not one, I would not necessarily say there is none. But other than that, it seems very close to the template that we populate each time we want to report a normal. We're not going to dictate a normal from the beginning. I have a normal template. I just add it and it saves me time. So it looks very similar to what I use.
Awesome. I think case 3 is again one of those cases that we have two views from it.
Yeah.
So let's go to the last case, which is case 4. This is the X-ray, and this is the report.
Yeah. So a comment for this chest X-ray. Probably it is a little bit blurry. The windowing is not ideal, so it looks more gray than it should. And I'm not sure if you can see and distinguish very well some fluffy opacities which are symmetrical in both lung fields, and they look like small flames, as if there are some dirty areas close to the periphery, not close to the heart, but more close to the periphery. So these are the findings that we have. Other than that, the heart is normal and the pleural spaces are clear. Can I see what the AI said? Yeah. The radiograph shows diffuse bilateral interstitial infiltrates, most prominent in the lung fields. The heart size is normal. The mediastinum is unremarkable. The body structures are intact. So diffuse bilateral interstitial infiltrates, I wouldn't say that they are diffuse. They are more close to the periphery. When it says most prominent in the lung fields, I don't think it is correct, because the infiltrates, or like the interstitial infiltrates, would be in the lungs anyway. They wouldn't be in the heart or in the bones. Okay, so when we're talking about infiltrates, also infiltrates is no longer a good term. It has been discarded. So we should talk about opacities, airspace opacities, or interstitial opacities. I would say interstitial opacities more in this case. Then the heart size is normal. Yes, I agree. The mediastinum is unremarkable. I agree. The bony structures are intact. I agree. Again, no devices, no lines. So now the differential diagnosis, it says pneumonia. The diffuse interstitial infiltrates are highly suggestive of pneumonia. So diffuse, we said it's not very correct. Infiltrates, I would not use it. I would say the interstitial peripheral opacities are suggestive of viral pneumonia. When we say pneumonia, we mean more bacterial pneumonia, which is more focal. But when we're talking about interstitial opacities, then immediately the differential diagnosis, the top differential diagnosis is viral pneumonia, something like COVID. Actually, this is a case of COVID, and it is a textbook case for COVID viral pneumonia. So acute ARDS, the pattern could be consistent with ARDS, especially if there is a history of acute illness or trauma. Yeah, a little bit stretched. With ARDS, you want really diffuse airspace opacification of both lungs. This is more in the periphery and more interstitial opacities. A patient who has ARDS is a patient who is intubated. There is no endotracheal tube, so the patient is clinically not in such a severe condition. So I would put ARDS very much at the bottom. I would not even consider it, I think. Pulmonary edema, although less likely given the interstitial pattern, I agree. Pulmonary edema should be considered, especially in the setting of heart failure or other cardiac conditions. I agree. Interstitial opacities, however, should be more central. These are peripheral, and we don't have cardiomegaly. So yes, on its own, interstitial pattern should be considered in pulmonary edema, but there are other things that do not make us happy with this diagnosis. There's no cardiomegaly, and it's more peripheral than central. About aspiration pneumonia can present with similar infiltrates. Yes, I would take that, but I would not use interstitial infiltrates. I would use airspace opacities. Viral pneumonia, we've already discussed about it. Definitely, it is the best diagnosis. I agree. And fungal pneumonia, certain fungal infections can cause interstitial infiltrates. I would take this as correct as well. However, most commonly, it's not interstitial pattern, it is nodular pattern that we see in fungal pneumonia.
Awesome, awesome. I love this. It's becoming like a panel. I need to go back to the recordings and then maybe use the transcripts because I've been using MedGem for other projects, and I know in other modalities it can be even more off. So I would say X-ray is one of its strengths. And based on what you mentioned, correct me if I'm wrong, but I think it's good, but it's not perfect. There is room for improvement in many cases. Now, one question that I have from you is that let's say you're in a clinical setting, you need to report some cases, and there is just one frontal view for that case. Let's say this is the case. Uh, if you are provided with this report as the starting point, would it help you and lighten some of your work, or would you prefer to start from scratch and write your own report?
I think based on these specific reports that I got, I would easily correct it much faster rather than going from scratch and use my own.
Okay.
I am not at 100% happy with the reports, but I am probably 70% happy. So I think I would it would take me much less time to correct them.
Awesome. Awesome. And I have one more question, if I may.
Sure.
So there are other pipelines. Now, with this setting, what we are doing is that we are giving one text some instructions and then the image and say, what do you think? And we get a report. However, there are other pipelines that are like end-to-end pipelines for some sort of classification. Let's say pneumonia versus COVID versus normal classification. I can ask the model in the prompt and say, hey, as the output, only give me these three numbers: 0 if it is normal, 1 if it is COVID, 2 if it is pneumonia. Technically, that's another story. I will add some comments at the end for those scenarios. But based on the report that you see, these are the insights of the model. Would you trust or would you think that that pipeline would be a reliable pipeline? Or as the explainable AI module, you would like to have a model which is way more sophisticated and takes into account more variables and findings, and then do something else with it.
Sorry, maybe I didn't understand very well. Like this would be in a scenario that I would be given only a cohort of patients with normal COVID and pneumonia, or there could be like other infections or lung cancer or ARDS, and then I would be asked to use only a pipeline of these three options.
So what I'm trying to say is that let's say there is a scenario when this pipeline becomes a black box. There's no report. It's just one number. Would you trust it? It just says
Again,
this is normal.
where would I have to apply it for?
That's a great question. Again, up to you. Maybe as the beginning, it's just for research.
No, I know, I understand that, but would I have, by using this pipeline, would I have to make a diagnosis for a known population or patients who are known to have either normal, either COVID or pneumonia? Or would it be an unknown cohort of patients that could have everything? If this is the case, then I would not feel confident using this pipeline that would have only these three options. I would definitely miss other options, other diagnoses. But if you tell me, okay, I'm giving you 300 patients, and these 300 patients, there are some normal, there are some COVID, there are some pneumonias, we don't know which one is which, and then we have this pipeline, yes, I would use it because it has only these three options.
Okay. That's interesting. Thank you very much. Thank you. Okay,
Ernest?
Sure.
Do you mind if I jump in and ask a question here? Because all of this has been very interesting. And you brought up at the beginning the few shot prompt, right? So meaning the ability to prompt per input, correct? And so I'll ask you, and then I'll ask Anastasia as well what she thinks. So if you do have two images, Anastasia is absolutely correct. It's a shame that the model is not going to interpret the two images together and learn the relationship between the two images, which is what Anastasia is alluding to when she says when she works as a radiologist, she wants to see both at the same time to make decisions. So potentially we could concatenate the images. So if patients have two images, you can concatenate them into one, and then you could do a few shot prompt and say, hey, by the way, this one is 2 views of the same patient. Please interpret at the same time. So that's my first question. Would that work well to be able to do that? And then the second question is, Anastasia has pointed out repeatedly that she has a personal preference, and it may actually be, from her department as well, and in how she reports in terms of terminology, description, the use of language, the way she reports, So once again, without having the need of fine tuning, which you could do as well, but then you would have to retrain on your own data set. She could, or you could put for her a few shot prompt that would accompany all inputs, and that would describe, it would say, my preferences as Anastasia is to use this, this, and this, and to report in this order, and please use this terminology. What do you think of that?
Absolutely, yes. Those are all great points. Again, confession, it's the design that I implemented, which becomes limiting here. However, MedGemma does have the option, and I've used that for even multi-view videos. And you can provide the model with like 2 different videos. There are ways for that. Regarding the style, few shot helps. You can also have a post-processing pipeline which uses another large language model to say, hey, these are like 1,000 different reports that I wrote before. Learn the style of the writing and apply it to this new one. So
Amazing.
keep the contents of the output the same. Don't add anything. Don't inject any new information. Don't remove anything. Just in terms of terminology, use my language. That's also possible with FewShot. It improves it to some extent. However, because of the uh, heavy training of the base model, even with FewShot, you cannot really change completely the style of reporting. Yes, sections, different sections, yes, but terminologies and terms used, it's a bit harder in my experience. But those are all great points and very crucial for designing all these pipelines.
Amazing. Amazing. Thank you.
Great. So we move to the last part quickly. And as I said, I would like to dedicate more time to Q&A. Same idea we have here. However, we do have consistency. So some helper functions and what we have at the end is a pipeline that can go over every single patient directory using this load patient and return anything that we saw in the data set. So patient directory, of course, it's just a directory address, but question text, you saw we had a dedicated file for that, impression text, and then the image, and then the support image, and also some auxiliary intermediary inputs. Okay, so if you do this, and for this pipeline, the one thing which is a bit different from what we had before is this question.txt. So it is the case that now the prompt is different for every single patient. So we read this text file and we put that into the prompt. Impression, we don't use it at all. It's just for acting like a ground truth for us. So that's the idea. The rest is just going over the directories and load the files and do all those things. We use the same model, we use the same pipeline. So here I'm just loading one of the patients. It's the first patient. Okay, so here we get the patient lists, and then we load the first patient data. So the question is that a 35-year-old male presented with fever, cough, and purulent platum. When you're not a doctor, why do you even try to read these things? I don't know. For 1 week, this was his chest X-ray. What is the diagnosis? And then the impression is what is provided in the textbook for us based on the insight from radiologists. Okay, so this is the chest X-ray. And then after in the book, they provide us with a support image to provide some further explanations on this support image. And the rest is the same. We just get the inference. However, instead of printing it here and checking what is going on, we save everything because this is a data set. So the idea is that we're gonna use this over tons of different patients. Yes, it's true that here I only have 3 patients, but if it was 3,000, it wouldn't change anything for me. Now, going to the results, for each patient, we will have one text file, and each text file includes the output from the patient. As you can see, it is not post-processed yet. So then you will need to write other functions to post-process this output. However, you can still look at the outputs and see what the model thought about this case. So again, Dr. Anastasia, could you comment on our first patient? So this patient.
You want me to comment on what I see on this chest X-ray, or should I read what the AI said?
Well, perhaps quickly give
What I
us some
think.
insights, and then we go to the outputs.
Okay, so first of all, it's technically it's not a good image, at least. It's very black, overexposed probably, or it is the way we see it from the book, because I understand that you took this image from the book, right?
Yes.
Yeah, anyway, so we can see that the cardiomediastinal silhouette looks good, but there is definite opacity. There is an airspace opacity in the right lung base. So when you see the image, the right of the patient is to your left. So in the right lung base, there is an airspace opacity, which is very, it's suspicious for a pneumonia. There may also be small right pleural space. I don't have a lateral to confirm. The rest, like the left lung and the pleural space looks good. I cannot exclude pneumothorax, which looks black on a chest X-ray, just because the X-ray is very black on its own. So I'm very resistant, I don't feel well commenting about pneumothorax, and the rest, like the bones look good and the abdomen looks good as well. So I would say there is a pneumonia in the right lung base, follow-up chest X-ray after 4 to 6 weeks after appropriate medication is recommended in order to see improvement or resolution.
Awesome. So I think the model is telling us.
Good. It's pretty good.
Yeah.
Yeah. Okay, I agree with most of it. I just said that I have some hesitation about the pleural effusion. It's because I don't have the lateral, and the pneumothorax because of the technical problems that we encounter in this chest X-ray.
Awesome. Okay, so we can stop here and go for Q&A, or we can go through other cases we have. I would say we can stop here and go for Q&A. But one thing that you mentioned, and I would like to echo, was the windowing and pre-processing the image. So we do know that clinically it's very important, and one of the attendees can take lead in this research. You can play around with the windowing setting for the input image and then see how the model's output is changed, whether it is on just one patient or a cohort of patients. And that itself can be a very interesting piece of research, especially because MedGemI is relatively new. I know there are many groups, at least I'm in contact with two of them, who are trying to benchmark this model and uncover maybe weaknesses and strength of the pipeline. Okay, so I'm gonna stop sharing and then see if there is any questions.
Actually, at this point, I can actually make a little comment on what you just said, which is great. And that is, playing around with the windowing. So the challenges with training these models is that, what's the input that was used to train it, right? So you can imagine that the repositories of images tend to be, good images, right? So images that have been retrieved that are diagnostic quality, right? And so what you're saying is, which is interesting, is that if you play with the windowing, you can actually get the algorithm to learn more from the various windows, which means brightness and contrast, by the way, for those of you that are not radiologists, and then would provide robustness to the model, right? And it's interesting that we observe that. I do a lot of work in ultrasound, and in ultrasound, it's exactly the same thing. It's a huge problem, right? And even more so in ultrasound because it's very operator dependent, and you typically get 15, let's say 5, 15, 20 2D images for B mode ultrasound, and then from the technician or the sonographer, and then you pick the ones that are best in order to make the diagnosis. And it's interesting, we've tried that. So when you do train, if you do train the model with multi-instance learning or something like that, where you have multiple images that are being used for the same diagnosis, so the diagnosis is there. It is interesting that the algorithm does learn that. So you can actually increase the robustness of what you're learning, so that it can tolerate, to an extent, of course, that if your windowing is off a little bit, it will still learn, which is very interesting. So it's but a very, very good point. Very good point. And now I think what you've also shown today, which is fantastic, is that Anastasia is still going to have a job. I love, because everyone thinks, oh, it's going to be so easy to replace the radiologist, but I really don't believe it. And the other thing too is, what we're showing now is quite, common, obvious, like pneumonia, COVID, right? I mean, that's chest X-ray, right? It's very basic. So you can imagine with other modalities, which are even more complex, that it's going to be even harder to just cut out the radiologist, right? I think we're getting close. I think it's wonderful, but I think it really is going to remain a tool for a long time to come. That's my opinion anyway. So, but thank you. We do have a question in the chat. And it's from Nabiha again. Thank you. I'm not too familiar with programming, but I wanted to ask what the feasibility is from a computational perspective when using multimodal LLM to simultaneously take multiple inputs, so frontal, lateral X-ray, to make a compiled report rather than the separate ones. So I think we addressed that a little bit before, but maybe you can reiterate that, Ernest.
Definitely. Thank you for the question, Nabia. As we discussed, it is doable. And how about this? I can add a block to the codes that include this multi-view input as well. in real world projects, let's say you're working with multi-sequence MRI, because X-ray, it is a 2D image, so it's not memory hungry. But with multi-sequence MRI, you need to have a considerable amount of memory, and that becomes a bottleneck. So then there are different ways to do it. There are tons of technical approaches for doing that. As I mentioned, one way in that case, if you cannot tolerate the computational load, is to get the inference per input, for example, MRI sequence, and then use another, preferably in that case, you should use a reasoning model and provide some more context to say, hey, due to some memory issues, I could not have a true multi-sequence pipeline. However, I'm just fusing different sequences through you, and now just combine these reports. So that would be one way. But for this specific case, for the X-rays, it is doable. Even on Google Colab, it is doable. I'll add one block to the codes, and you will have them on our GitHub repository. Please check it again in a few days. To follow up, what that alter the efficiency of the algorithm that is being used, or would that not be a concern? Well, the efficiency of algorithm, what we expect, and I believe that will be the case, is that it will be improved, because as Dr. Anastasio mentioned, it's unfair to the model to be blinded to half of the information that we could provide to it. So I believe if we have a multi-view pipeline, the efficiency and the performance level will be improved. However, there are some cases. These days, I'm working with echocardiograms as well. And with echocardiograms, my experience is that, of course, the level of noise is insane, and it is video, so memory intensive tasks. However, in some cases, you can distract the model as well. It is counterintuitive to some of the cardiologists that I work with. However, that can happen. It's just because the models are not mature yet. As I said, MedGemma is amazing with some modalities. For X-ray, for sure, it's one of its strength. You saw it today. But with other modalities, if it was not part of its training, it makes a lot of mistakes.
Okay, we have a question from Mohammed in the question and answer box. We're multitasking today. Why would you prepare an RGB image for input? That's the first question. The second one is, can fetal MRI images be used as input to the model? Given that fetal MRI is more complex compared to other MRIs, how does this affect the model's performance or X-ray images?
Thank you for the question. So, RGB images are common in computer science work. There are huge X-ray open source data sets that come in the form of RGB. For the JPEG files that I showed it to you, they were just screenshots from a textbook. But other than that, there is no reason. If you're in a clinical setting and if you are connected to the PACS, what you work with is likely going to be DICOM, and there is no reason to convert it to RGB or any other format. DICOM is a single channel for X-rays at least, and there is no reason to convert it. For the second part of the question, I do not know what will happen to the output for sure. Technically, it's doable. You can test it. And you need to benchmark the model. You need to curate a data set and see how it works. My intuition is that those complex modalities were not part of MedGemma's training, or the model is not that strong on them. So I don't expect you to get great answers for echocardiograms. I can tell you, especially for stress echo, which is a bit rare, transthoracic is more available online, but stress echo is rare. And the answers I got out of the pipeline were almost all off. Nonsense answers were common. So just be careful, but you can curate a small validation data set. It can be just 20 patients, and then you can see what will happen.
I'd also add, I believe MedGemma is 2D is 2D natively, correct?
You can input 3D as well. There are some approaches you can because it accepts multiple 2D images. So for example, if you have a video, you can go for frame by frame. If you have 3D, you can provide 3 different views from the image. So it is doable. And I know there are other groups that are working intensively to provide uh, modality specific multimodal models like for just brain MRI. They're doing that. And over time, I'm sure we get better models. The next version of MedGemma, if there is something out, it will be much better than this. If there is no other questions, I would like to add one quick technical comment. We briefly talked about this idea that sometimes you want to create, for example, classification pipelines. In that case, your prompt is going to be, hey, give me 0, 1, or 2 as the output, exactly this, don't do anything else. And then when you get the outputs, because these are based on large language models, sometimes it does not strictly follow your instructions. Sometimes you say, hey, don't give me anything else, just 0, 1, or 2. And still it says, okay, I'm giving you 0, 1, or 2. No matter what you do, there is always some deviations from the instructions that you have. So for that, there are so many different tools. Of course, as you can imagine, you can post-process the outputs. However, there are libraries. LangChain is trying to organize the whole prompting and then the output parsing pipelines. There's another one called Pydantic. It's amazing. There is another way that you can use another LLM for the output to reconstruct and reformat it the way you want. It's always a challenge, and even if you pay for the most advanced models, for the latest version of reasoning models from Google and OpenAI, you get the same issues.
Okay, we have one last question. And sorry, I just wanted to confirm for the previous question for Mohammed. Yeah, the fetal MRI, as Ernest said, you would need to test it, right? Because we don't really know. It was trained on MRI data for sure in the 2D, like as 2D images, but we don't know the content for fetal MRI. So just as Ernest said, you just need to test it to see what it's going to come back with. My guess is probably that's going to be a smaller portion of training data of fetal MRI, so it probably will decrease the performance. Last question from Juan Castro. Would it be worth to add some type of filter of image quality, so windowing, rotation, etc., to the model so that it won't analyze a very poorly taken image or that the outcome comes with a warning of the interpretation? Good question.
Absolutely, yes. And Dr. Anastasia can provide more comments. Based on my limited knowledge, there are some cases in clinical settings that you have what you have. There is no other options. I was trying to flag out some of the echocardiograms that were very poor, but then it wouldn't be clinically interesting because they said, hey, the patient is overweight. What can we do? We cannot improve the quality. So in those cases, the question becomes whether we should use the pipeline at all or not. But yes, it's amazing if we can at least gauge the uncertainty of the model or prepare some precautions.
Awesome. You know what? We have to go for lunch. But I'll just ask Anastasia. That's a great comment. Like, so if we're filtering these images going into our pipeline, you realize that afterwards, so if you train it that way, or if you know, in this case, it's pre-trained, right? And so you're filtering out these images, and so you're saying don't look at these. Then you're changing the pathway. So that's what I'm going to ask Anastasia. What do you do, Anastasia, when you get an image which you're not happy with?
So good question. We try to manipulate it as much as we can. That is possible. I mean, if the patient is positioned completely not straight, you cannot change that. But with windowing, we definitely play all the time. Windowing is something that we can do on our screens.
Yeah.
Other than that, we zoom again, but we cannot make the patient be straight. Like,
yeah,
windowing is all we have, and zoom, I would say.
yeah. So thank you.
We use all of it.
That's an excellent answer. So that's where, you know, when I go back to my example with ultrasound, we need the pipelines to be able to work like you or work with you. And so if we exclude images that don't meet, you know, a perfect, you know, criteria, then we're not doing what you're doing, right? Which is very interesting. And so we should really find ways to make our models more robust to do what you're doing. So meaning that you can play with the windowing, you can be more tolerant of the positioning in order to give the answer. And I'm not saying that's easy, it's not. But it is, you know, what an excellent question, because that is something to take into account. That the more you play with the input of the image, the less generalizable your model is going to be. And once again, we see, you know, how more robust the well-trained expert radiologist is, right? So there's the challenges is that, you know, Anastasia has a whole set of tools at her disposition in order to do her job. And so really we should be working towards making AI another one of those tools that she will use in order to do her job. So
The other thing I wanted to add here is that I think that someone mentioned if we have to put a disclaimer, we do add this in our report. So if the patient is rotated, we will say allowing for the patient's rotation, allowing for the technical artifacts. So maybe it would be useful if the AI models could be trained to see the deficiencies of the technical problems and say, okay, I have identified this problem. So based on this is my report.
Absolutely. Excellent. Yeah, agreed. And that is something that can be done. So that's excellent. Okay, so at this point, I'm going to say, let's have lunch because we have to be back at 1:30. Please don't be late. If you could actually rejoin before 1:30, I know it's short, but we're keeping the whole conference short to accommodate the different time zones and to accommodate people's time. But the keynote address is at 1:30. It would be really nice if everyone could be back for 1:30. So you have basically 24 minutes to have a quick snack and bio break, and we'll see you back here at 1:30. Thanks, everyone. Excellent. Oof, that was close. We have the privilege today of having Dr. Narinder Paul, who is the chief of the Department of Medical Imaging at Western University and its affiliated hospitals. He earned his medical degree from Southampton University Medical School in the UK. He previously served as division chief of thoracic imaging in Toronto and was professor at the University of Toronto. And he's also held numerous administrative and research roles in the past. So today, as the title says, he will be talking about the AI across the continuum of care, transforming the patient experience. And Narinder, I am going to hand it over to you. And once again, thank you very much for coming to address this conference.
That's great, Pascal. Thank you very much. Can you hear me?
Yep. Perfect.
Great. Now, for some reason, you can't see me, but that may be a button that you press seeing what I look like normally. So, so I don't know, my video was working, but it's not working now. Let me, oh, here we go.
Oh, there you go. Perfect.
Now you're sorry.
Now we can see. Yeah.
Thank you very much, and thank you for the invitation to sharing some ideas with the participants here. So, and thank you for that kind of introduction. Some of the, I'd like this to feel more like a conversation rather than a speech, because I really want to stimulate some of your thinking in terms of how we can actually improve patient care for a common areas of diseases. And part of this reflection is informed by my work as a cardiothoracic radiologist. Part of it's informed by my work in research. Part of it's informed by my administrative positions in the hospital and seeing how we have to organize things for improving patient care. But a lot of it actually is informed by my provincial role as the provincial lead for oncology imaging and intervention. And I see where we need to do things differently on a sort of provincial basis. So, you know, bear with me while I sort of share these thoughts with you. And let me just see which button I need to press to forward the slides. Here we go. I have no relevant disclosures for this presentation. So the objectives by the end of the session, the anticipation is the participants will be able to do three things. One is to understand key determinants of health outcomes. The second is to have be able to describe the patient's experience in healthcare. And thirdly, to evaluate opportunities for AI to address health inequity issues that exist in our society. So with that, the way I've structured this is to talk about causes of global mortality, key determinants of health care inequity, and then evaluate opportunities where AI could play a role. So the United Nations and the World Health Organization look at countries in various ways. One is by the income a country has, because that can sort of reflect what the healthcare infrastructure is. So if you look at the 10 leading causes of death in countries around the world, this is in 2021. And if you look at low income countries, if you look at low to middle income countries, if you look at, when it goes to the next slide, it's just got the circle of death here. When it goes to, okay, it's not advancing. Why is that? Oh, that's interesting. Oh, there we go. Now it's advanced way before. Here we go. Apologies. So low to middle income countries, upper to middle income countries, and high income countries. Something becomes very obvious that irrespective of the GDP of a country, there's a common cause, ischemic heart disease. And the next common cause amongst that is stroke. So both are atheromatous diseases of the arterioles, right? So whether you get a plaque going off from the neck vessels going into the brain, or whether you have plaques in the coronary arteries, they still are major causes of death, irrespective of how rich a country is. And that's really interesting because Let me share with you a picture of a CT scan of a patient I had for a completely unrelated medical condition. And I was doing a CT of his chest. So this is not a dedicated cardiac CT. And there's a couple of things you can see. So the pictures are taken with the patient on their back, looking up at the ceiling. And I've shown you the picture of the heart, which, if you're familiar with the anatomy, there's 4 chambers. You have the left and right atrium, the left and right ventricles. The white you see in the ventricles is iodine that we've injected through the blood vessels, and it circulates around. And we take a series of images when the organs are opacified. So if you look at the left picture, there's an orange bracket and a green bracket. The green bracket shows you the normal thickness of the muscle overlying the left ventricle, and that's a normal pump of the heart that that pumps blood out to the brain. If you look at the orange bracket, you see the muscle is markedly thinned. Excuse me. And there's a fatty, sort of a black stripe at the apex, right? We know that's fat. Fat should not be in heart muscle. And the only way that happens is if you've had it deposited there. If you look at the picture on the right with the blue bracket, you'll see there's a lot of bright stuff in that left anterior descending coronary artery. That's calcium. And in between that calcium, if you can see my arrow here, this is what the artery should look like. It should be nice and kind of grayish with the contrast. This is calcium. This is diseased artery, disease artery, disease artery. This patient has a lot of disease in the left anterior coronary artery. And what's happened is he's had a major blockage in the LAD, and that's caused devascularization of the left ventricle. The patient's had a heart attack, and they've replaced muscle with fat. So we know that for sure. This patient's got heart disease. But when you look at this vessel, so there's nothing we can do about that left ventricle there. But when you look at this CT, you've also got major disease in that right coronary artery. So this patient has already had an infarct, and they're liable to have an infarct in that right ventricle. Now, you only have 2 ventricles. If you infarct both, you're dead, right? So the important thing about this case was to say this patient needs to be under secondary prevention to reduce the risk of that heart attack in that right side. And the entire family needs to be screened in case they're at risk of heart disease, right? So you screen for primary prevention of the rest of the family. And the reason I say this is we know what that process of developing disease in the coronary artery looks like. So the vessel segment to the left is normal coronary arteries, here to the left, and here is where none of you want to be, okay, when the artery is really kind of full. So we know there's a few things that take place. You get some inflammation that causes a white cell infiltrate into the wall of the vessel. Then you start getting muscular hypertrophy in the vessel wall. It starts to get thick. Then you get calcium buildup, and you get a buildup of fat in the lining of the blood vessel. And if that fat gets to a certain size and constituents, it's fragile. It can bleed into it, right? And then you get rupture of that plaque, and then you get a blockage of that coronary artery. And if you think about people in your life, your parents, your grandparents, many of them will have this process at one level or another. Hopefully none of them get to the picture on the right. But this is important, right? Because you can have somebody who's walking around, no symptoms at all, but the plaque can rupture and suddenly it blocks and they have a fatal heart attack, right? Now, the reason I have elaborated on this is we can detect some of these processes on CT. We can detect the thickening of the blood vessel, we can detect calcium, and so on and so forth. And we can do that with a calcium CT, a CT that looks at calcium without any intravenous contrast. You look at the amount of calcium buildup, and then you either reassure the patient or put them onto medical care. Or you can do a CT coronary angiogram if the patient has some symptoms, and you can grade the vessels, no disease, all the way to something needing attention. And that repair can be either with a small stent that's put in the coronary artery, such as here, or it may need a bypass surgery, such as here, depending on how bad it is. So we've known this for decades, right? We've had cardiac CT for at least 20 years. We started at University of Toronto in 2004. We've been able to put stents in patients. We've been able to bypass grafts to patients for many, many, many years. If that's the case, why do we still have coronary artery disease as a major cause of death in the world? We have these equipment everywhere. We have the surgeons everywhere. We have the cardiologists everywhere. So why are people still dying in poor countries and rich countries around the world, still to this day. And that's despite the fact that countries are spending more and more of their GDP on healthcare. So we're spending more, but patients are still dying. And that's because we don't have equitable access to healthcare, right? People who are very rich, they have access to healthcare, other people don't. So I just want to take a bit of time to talk about some of the things we know, and this is certainly from a Canadian lens, but I think it's relevant everywhere. We know that if you look at certain indicators in a country, we know they're doing well or they're not doing well. If you look at life expectancy over the population, if you particularly look at infant mortality, right, we know that's a sensitive indicator of how a country is doing. If you look at the way patients perceive their own, or the community perceive their physical and mental health, you look at infectious diseases and chronic diseases. And then if you look at the determinants of how healthy a society is, you look at the social environments, you look at the physical environments, you look at childhood development, look at the conditions that people work in, you look at any social protection. And particularly if you look at inequities in society, right? Not everybody has the same access to healthcare. Not everybody has the same attitude to healthcare. And in particular, there are things that we can change and there are things we can't change, right? The non-modifiable risk factors for heart disease is age. You can't make yourself younger all of a sudden, right? You can't change your gender. And we know that men and women experience heart disease in different ways. Before the menopause, women are relatively protected from heart disease, but after the menopause, the rate of heart disease accelerates in women to be equal to that of men in their 70s, right? This is something that's not well understood. And race, we know that different ethnicities have different incidence of ischemic heart disease. But there are modifiable factors such as smoking, high cholesterol, physical activity, obesity, controlling diabetes, a diet, and alcohol. So we know there's things that we can all do to make our risks lower. But what about patients who don't have access to healthcare? What about patients in every society that we have, rich or not rich? Socioeconomic status. We know that gender difference makes a big impact on healthcare. We know that your age, whether you're very young or very old, you don't have the same access as someone who's middle age. We know that sexual orientation makes a difference. We know that if you're mentally or physically disabled. We know that if you live in cities versus living in towns, if you live out in the countryside, you don't get as good access to healthcare. And we know certainly in Canada, immigration status, people are Canadians who are not Canadians, very much difference, race, culture, and indigeneity. These have all been shown to make a difference. And my hope for AI is that we can reduce that inequity through some of the tools. And that's what I'm going to address in the main part of the talk. But I also want to challenge some terms that we use. And you may have seen this slide before. For a long time, we talked about equality. Well, look at these 3 children. One's tall, doesn't need a box to look over the fence. One's sort of not so tall, and they do need a box. And the one's short, but even with the same box as everybody else, they still don't have the ability to see the game. So if you talk about equality, you're trying to give the same support to everybody, whether they need it or not. It doesn't work. You can talk about equity, meaning support of what people need so they have the same access. So if you see this picture here, the tall kid doesn't need the support because he can see over the fence, and the smaller child has what they need. So you can talk about supporting people in a way that they have the same access. But surely, truly, what we really want is justice. Don't we want to remove the barriers so you don't have to support specific individuals because they don't need it, right? Because there are no barriers in the way for them to access what they need. And so I think more and more in recent times, we're talking about justice as opposed to equality and equity. And I think that's the way we need to go as a society. Important point here, you can have ideas, you can have thoughts, but if you don't do anything, it's a waste of time, right? So vision without execution is hallucination. I really like this comment, and you might want to think about that. So what happens to patients now? And this is the sort of journey from my perspective. And you can think of, if you have a friend or if you have a relative that's had any sort of medical condition, you can see what they have to go through. At some stage, the person is aware of their symptoms. They have to seek help. In Canada, that would be a GP, a primary healthcare specialist. In some countries, you may not have access to them. That specialist will come up with some sort of idea of what's going on, a differential diagnosis, and then they will either treat you in the office or they will refer you on to a specialist. That specialist also has to take a history, and they have to consider what the differential is, what sort of tests they need to do to confirm. And usually that's a diagnostic imaging scan of some sort. That scan will be performed with a certain protocol that's tailored to the patient. There's a report that's generated, and then generally, it needs either medical or surgical care, right? So ideally, that is a seamless process, ideally. What happens in someone, and I'm not talking about someone who's educated, who's rich, and who can access all these things and can self-advocate, but a patient who's going through, let's just say, ischemic heart disease, developing those coronary artery diseases, at some stage, they have to be aware that the symptoms they're getting are relevant to their heart and that they should seek further attention. They have to have access to that first level of care, and they have to be able to communicate what their symptoms are to the patient, to the person who's looking after them, right? So awareness, access, and communication are really important. Then when they see the primary healthcare provider, that person needs to be able to interpret the symptoms in a way that's meaningful to that patient. And they also have to know the latest guidelines of what is suggested and what is available. There's like thousands of guidelines printed every year. No family doctor has the possibility of being up to date on all of those. So how do we access those at the point of care? And then an appropriate referral made to a specialist. The specialist also has to then be able to access their data to say, for this particular person in front of me, whether it's a man or a woman, young or old, taking into account their ethnicity and any other things, what's the appropriate test for them to have done if there is a test to have done? They have to need to know where that test is available, what's the shortest wait time that's accessible to the patient. The imaging test is scheduled, it's protocoled according to the needs of that patient. So, if you're going to do a CT scan of the heart, you wouldn't use the same protocol for someone who's 120 pounds as you do for somebody who's 320 pounds. You shouldn't use the same protocol for a male or a female because the cross-sectional body is very different. And then you have to have some way of making sure all the important findings are captured on that image and put into a report. The report has to be concise, has to be informative, and it has to be available to anybody who needs to be able to view that in a timely fashion. That report goes to the specialist and to the primary healthcare referrer. Then they have to think about whether there's medical treatment, and they have to look at the efficacy for that particular person, for their gender, for their age, for their race, and any side effects. And lastly, if there's surgical treatment, it has to be appropriate for that patient using the same demographics that I've already mentioned. So where may AI help with this? So this is just flight of fancy. Some of these things are true and happening now, but there's nothing that's end-to-end that I know about. Well, in terms of awareness, some people really aren't aware of what's going on in their body. I've seen patients who present with a lung cancer that's a tiny thing that's the size of a plum. And I've dealt with patients who's got a basketball in their chest that's eating away through the chest wall, right? So clearly these patients, and they have both had no symptoms, so clearly these patients have no awareness. So the question is, in order to raise awareness, as we're developing devices, wearables, for example, that can monitor heart rate, the pulse rate, the frequency, the variability, maybe blood pressure, maybe other things in time, maybe it can say there's a change in the patient's composition, some sort of change that's going to alert them that there's a problem. Otherwise, they have symptoms. How do patient go from symptoms or awareness to seeking help? Well, maybe it'd be nice if they had some sort of chatbot type facility in their language, which they could talk to because they can't access a primary healthcare physician. And this chatbot, it has a repository of common symptoms of common causes. It generates data over time to inform itself so that it refines itself for that particular age, that particular community, that particular gender. And it can start saying, well, actually, you might want to look at this or look at this. It has to be better than Google, because everybody I know who looks at Google thinks they got cancer, right? And that's not the case. So we have to do better than that. The directory can also tell them, for what you're looking for, the nearest primary healthcare physician who speaks your language is here or wherever. And that you may be able to get a virtual interview with that person before you actually have a physical exam, right? So access becomes important because not everybody can travel. The next thing I'd like to see is a clinical decision support tool where the family doc is interviewing the patient, taking down a history, but they're not actually writing it down. maybe you're using natural language processing, maybe this is sort of video recording, I don't know. It starts to populate a field of inquiry. This is your age, these are your risk factors. There are standard questions that we ask as physicians, and you could be filling in that form automatically while you're having the conversation with the patient. And then that populates clinical decision support. And that could say, okay, for the things that you've told me, the guidelines would suggest this is the next level of investigations. This is what the patient needs. And then you can agree or disagree. But then it could also point you to who the specialist is that you need to refer to. It can automatically fill in the referral form, the consultation, because it's already recorded everything. And then it makes an appointment with that specialist because you have access to their scheduling diary. And you say to the patient in front of you, Tuesday, 5 o'clock or Wednesday, 6 o'clock, can you make it? And then you book the appointment. Same thing for the specialist. When you go there, the referral's already filled in. They already have access to the history that the primary care physicians made. Now, I know there's a whole lot of regulatory stuff behind this, but I'm talking about from the patient's point of view if we're going to make a difference. You don't want to have to go through the whole thing again. And again, the specialist will have some sort of decision support tool to help then say, for this particular indication, what do we do next? When we go to the diagnostic imaging, the specialist should be able to book a CT scan or an MR scan, just like you book an airline ticket, right? You know what you want, it fits certain parameters. There you go, according to the date and the time that the patient and their family can make it. They get the protocol, they get any preparation already handed to them in terms of, fast in the morning, don't eat or drink, that kind of stuff. And then when they get to the scanner itself, the CT scanner or the MR, but let's talk about CT, is already taking into account their demographics, their body type, the body composition. It changes the protocol in terms of the X-ray beam according to what's required for optimal image quality. You adjust the scanner for the heart rate. We do that already. And then as the images are done, AI is used to say, okay, well, this is my standardized report. I want you to pick up the pertinent findings and then I'll check them over. And this is why a structured report is important. We have radiologists, they're very, very good. But some people are like Mr. Spock, they're very concise, and some people like Shakespeare, right? They take many pages to describe the same thing. And somewhere in between, we need to have a happy medium. And the point of the report is to make sure you pick up all the pertinent findings and it's comprehensible to the referring physician so they understand what you're saying and they understand what the next steps are. And this report could be translated into multiple different languages because you have an AI tool that's allowing you to do that. And it should also be translated into a language which the patient can understand. So they don't need all the technical gobbledygook. There may be a report that says layman's language, this is what's going on. The medical management, again, I mentioned AI can help to make sure it's personalized and directed. If you take 45-year-old men of different ethnicities, the same medication will not work as well on each of them, right? And then if you add in women, if you add in different ages, if you add in different comorbidities, it's a lot to take in for any particular specialist. So you have to make sure that you have a tool that helps you. And lastly, the same with PCI or surgery. You have to make sure you've got a tool that's going to help you gather all the world's data on what you're trying to propose for that particular individual and make sure you have that collective experience to inform your decision making. So that's pretty quick. I hope I haven't gone too quickly. But in summary, what I want to impress upon you is that despite the fact that we have a lot of things in place, the equipment, the specialists, across many, many countries, we still have across many GDP the same major causes of death, right? And I believe that's because we have inequity in our societies, all of our cities, all of our towns. Despite all the things we've tried to do, we haven't been able to make a major shift in socioeconomic status. You can't change somebody's gender in terms of their genetics. And there's a whole bunch of other things that you can't change, and we know it makes a difference. But I think I've tried to indicate that there are multiple areas where AI has an opportunity to improve the current experience of healthcare. And if you've ever talked to a patient who's come in through the healthcare system, you know that they have a very different experience depending on their background, the socioeconomic background, their cultural background, the racial background, their gender, and also where they live. So I think there's an opportunity for AI to be able to address some of these issues. It won't make those issues go away, but it may be a leveler to some extent in access to care and also how patients experience care. It's all about the heart. Thank you very much.
Thank you, sir. Excellent talk, of course. I will open it up to questions. So please feel free to type in the chat. You guys, you have the option to use the question button as well. And you can ask, put your hand up, and I will unmute you, and you can ask the question verbally. So please consider asking a question. Just to get it going, I will ask if you had, well, I don't know if unlimited resources, but if you had the ability to make change today using AI based on what you've just discussed, what would your plan be? What would be the sweet spot? What would be the first target for you using AI to address the issues that you've just talked about?
So what I would do, and I've actually pitched this to the province, I would use AI to look at where the population is that's at risk of disease and use it to plan the resources in those areas, right? Because we don't do that well. If you look at the way healthcare resources are planned, a lot of it's centered around urban areas. Some of it, hypothetically, is centered around where the politicians in power have their constituencies. But rarely is the plan made in a way to say, let's plan for the future, let's plan for now. We've got all the information. You know, every country has a census. How many men, how many women, how many children. Every country knows what the sort of comorbidities are in those patient populations. But we very rarely plan for that, right? The only people who plan are people who plan schools, people who plan old age homes, and people who plan building houses, right? So if you look at where people are building houses, they know where people are moving to, right? So they kind of do this thing. If you look at the schools, they know where the young children are going to be. If you look at funeral homes, they know where their businesses are going to be, right? The government has all this information, and it has all the information from hospitals about patient demographics, how old they were, who got admitted. But because there's so many different pieces of data, integrating that into a comprehensive plan to say, this is where we should be investing, I think that's where AI can come in. Now, AI's, people see it as different things. People, I mean, some people may see it as a way to earn a fortune and retire early. Okay, fair enough. I see it as a way of taking multiple data sets, which are complex, and integrating them, saying, this is my vision. This is what I want to know. Help me create this vision with the data that I need. And I think that is going to be a real powerful tool. And why I say that is because individual hospitals can sweep their processes up, right? I can do a better job in booking patients in my hospital. That does not help everybody outside my hospital. So we need to change things as a system.
So what I really enjoy about your answer is, you know, what I talk about, you know, in our courses as well, and that is what AI can be used for is not necessarily the sexy, you know, perspective of AI, which is to, you know, diagnose this rare condition, right? The usefulness of AI can actually be logistics, right? Or planning. And it is actually currently being used and for that purpose. And I really appreciate your perspective on that, especially being in a leadership role as you are. Because I believe, and I believe with you, that I think that's going to be some of the most impactful uses of AI is exactly that. So thank you for that. I appreciate it. So we do have a question in the chat. I'm going to go there from Jesse. AI will obviously be useful for many of those key steps. However, some of them may not necessarily require AI. Transfer of, oh, sorry, someone put another question and it popped up on my screen. Transfer of patient data between systems, etc., and are still very difficult to implement in clinical settings. Here's a question. What do you think are the main barriers and how can these be overcome? Tricky
So I think if you want my honest opinion, I think the main barrier is people believing that it's going to make a difference. So I believe in function, structure, sustainability, right? The function is what do you want to do, why you want to do it, and what's the so what? Like if you succeed, what difference it's going to make, right? And if you have a compelling case, I think all the other things like the structural thing, like the regulations, because the regulations are things that really slow us down. I mean, patient privacy and a whole bunch of things. These are important, but you need to understand that these need to facilitate improved patient care as opposed to hold it back, right? And so having enough people in positions of power who believe that we need to change, because I'm not sure we have that. B, that change is possible, and C, that change is impactful, right? If we have those three things, in my career showed me that everything else is possible, right? You have the people around the table, you have to have multiple government agencies around the table because it's not just one. And you have to appreciate that they have a job to do. So this is really important. If you're a physician leader, you will know that the last thing you want to do is bang on the table and say, you guys don't understand, patients are dying and you're in the way. You can't say that because everybody wants to do the right thing. It's just that we have to agree what the right thing is and come to a common purpose. So I believe if you have an understanding of what the current problem is, you have an understanding of that there is a solution that can make it better, and that if we do the right thing, there's going to be a significant improvement in patient care, then people are listening, right? And you're absolutely right. There are AI tools. I'm reading the second one. There are, as I said at the beginning, there are AI tools in parts of this, and they're coming in. But what we don't have, it's like our PACS system in Canada or in Ontario. We have like 100 million different PACS units. Like none of them really talk properly to each other. So if you don't design a system end to end, it makes it kind of chunky, right, and clunky to talk. So that's why I want people to be able to see this end-to-end thing, because the only way you'll see that if you truly make it about the patient. If you make it about the system will perpetuate itself. So you have to make it around the patient and see from a patient's perspective what the obstacles are. The patient's perspective may not be wanting to consent for a surgery. It may be, I can't actually get to see anybody to talk about my symptoms. Right. And for many parts of the world, that's the problem, right? It's not about getting the surgery. That's the issue. That's why I'm talking about the end-to-end.
Mm-hmm. Thank you. So Hamza has a question. I'm going to let them ask it. Hamza, all yours. Unmute and then ask your question, please. Are you okay to unmute? You should be you should have permission to unmute. Huh?
Sorry, can you guys hear me?
We can hear you. Perfect.
Hi, my name is Hamza, fourth year medical student from Western. Dr. Paul, thank you for your wonderful talk on the equity and justice of AI. I think this topic is, of course, a very rich one, and even within AI implementation, there's inequity in the models available to different institutions and different sites. Of course, the higher quality models, the upgraded models trained on better data sets and like better infrastructure to support it would cost more than, and maybe institutions with higher budgets could access those ones, and then institutions with less budgets would be unable to, I guess, access that same improvement to patients and risk factors. So of course, from the physician side of things, our focus is on improving the patient care side of things and trying to get the best services for them. And also given, I guess, from a management point of view, I guess, what do you see the AI or the justice that can be done or the equity that can be done to kind of bring those tools to institutions at London or at other peripheral sites, maybe outside of more urban areas?
Yeah, great question. Two things. So I've got an administrator hat on as well, right? I run a department, I have to look at the cost of things. But sometimes you also have to look at the cost of not doing things. And so, for example, there's always a cost to healthcare, there's a cost. So let's just say somebody presents late with heart failure because you haven't picked them up early. So now that patient's in ICU or they're in medical ward for weeks at a time, they survive, but with a poor quality of life. So they're not working, not paying taxes. They may be on getting benefits, or the patients, their family may have to take time off work to look after them. They'll keep coming into hospitals for, repeat visits. So it's very expensive from a financial point of view. It's also ethically and morally wrong, right? If we can do something at the beginning, right, to make people have a fulsome, wholesome life. So I'm going to park the ethics piece and moral piece because I think that's the most important part. Let's just talk about the money piece, because often people say, well, the money. So nobody looks at the lifetime costs of not doing something. If you can actually detect a lung cancer earlier, if you can detect coronary artery disease earlier, it's way cheaper for society and way more beneficial to be able to do this. So that's why I always talk about investment in patient care as opposed to a functional code. So that comes around to your question about, if you have different versions of AI, my direction would be, let's build something that has a common core to it, right? End to end, right? And then you could have, so it's, for example, it's like flying in an airplane. You can buy economy, you can buy preferred, or you can do what Pascal does, go business, right? But the rest of us sitting in cattle class, right? We still get on the plane. We still get from A to B. So it may not be the same cost, but you need to have the same functionality. I don't think we're ever going to be in a society, unless we have universal income and nobody works, where everybody gets the same thing, right? I just don't think that's practical, because people will always want to have something extra. But what you've got to ensure is that you have a minimum core protocol that's functional for all those steps that you want to do. And then over time, you can invest in more, but you shouldn't have to buy a new system. It should be upgradable, just like buying a ticket with your favorite airline. You can go, economy, preferred, or business. And that's the model I prefer to see, as opposed to you're either in or you're out, because that's what's been happening to date, right? And you have to have governments that see this as an investment in the patient care. And in order to have that, you have to have institutions that have done the economic analysis. When you get these things in play, you've done a pilot study to say, okay, well, this is what it cost us. This is what we had to put in place, but this is actually what it benefited to us and our society, right? So you put an economic number on a cost number on that. We're not very good at doing that outside of things like cancer and interventional radiology. We're not really good at doing that on the rest of, say, imaging, for example. But I think it's something we're going to have to do, right? So I don't know if that's answered your question, but I actually think there should be a common platform, and you can have various grades of it, but you shouldn't be you're all in or you're all out.
100%. Thank you, Dr. Paul. Yeah, it'd be interesting to see next year with the quantum computing powering these future AI models, where we'll be with that. Thank you for answering my question. And thank you for
Actually, I'll make a comment, because that was a very interesting comment that you made, Narinder, when you said that we don't model, the cost of not doing something. And so to bring it around to AI, and actually, you brought up quantum computing as well. So one of the challenges is, in one of the types of machine learning, it's called reinforcement learning. And reinforcement learning should be, a very good modeling tool for medicine. And it has been used in medicine. It's used very typically in gaming, right? So first-person gaming software uses reinforcement learning. But the challenge with training that kind of software is that you need all of the possibilities in order to teach the algorithm which one to choose. So it's called a state transition, right? And so in medicine, the problem is the data we have is all about what we've done. So yes, some of what we've done doesn't work well, and some of what we did work well, but we don't have the full spectrum of all possibilities. So that's an excellent comment when you say we don't actually model or take account of the cost of what we don't do. And so that ties into the challenge of reinforcement learning and machine learning, and one of the challenges of how we're going to be able to adapt to this using AI. So I just thought I'd bring that in, because this is a conference on AI. And so sorry, the last thing to say is that quantum computing won't help us with that, right? Because it doesn't matter how fast we can compute and how large a data set we can train. If we don't actually have the data, then it's not going to change anything. So the challenge is going to be to get that data. So modeling the cost of not doing is what we need, right? So we need that data to teach the algorithm. So anyway, I thought that was great. We have a question from Addison. So Addison asks, how do you imagine AI could be utilized For scheduling patients for scans when currently in Canada, it has to be through referral through family doctor or walk-in clinician. Would this system have to change alongside the implementation of AI?
So really good question. So there are things, I think there are, so part of what I talked about with the scheduling was for when somebody's seen a family doc or a specialist, but there is the question, can patients schedule themselves if they haven't seen anybody, like using some sort of checkbox, I've got these symptoms and all the rest of it. I think we're not there yet, to be honest. And I'll tell you why we're not there yet from my own personal experience. I worked a long time ago in a trauma department, emergency department of a large regional trauma center in the UK. And what struck me there was that you'd have people walking through the door or hobbling through the door. There'd be people, the majority of people would be coming in with what I'd call minor injuries, which they thought were severe. And then you'd get the older people, like the farmers and the older ladies who'd fallen on their hip, or the farmers who had a tractor fall on them 3 days ago, but they were forced to come in because somebody said, and they all had nasty injuries. The people who came in from the soccer field, never anything wrong with them. And so what I'm trying to say, self-selection doesn't really work the way our society is at the moment, right? Because people have different perception. So, and also the imaging test we do, there is a capacity limitation. So I still think for the foreseeable future, maybe not forever, if you've seen someone and say, you need a test as an outpatient, that's the opportunity, I think. I think each department needs to have a certain amount of scheduled time for outpatients. We have that now, right? We just have a process where the GP sends in a request, we bounce it back, say it's the wrong form, it comes back in again, we say we can't read it, it goes back and forth. But what I'm saying is when a request comes in, or we give an appointment to the patient and the patient says, I can't make it, right? And my family aren't around or something. So what I'm saying is we can condense that timeline. So when somebody's in front of a GP and they say you need a CT scan, they can access that scheduling just like booking an airline ticket, and they can say, these are the times available at the hospital that's closest to you. Can you and your family make it for that time, right? And then it saves all that nonsense going on, right? There's another thing that we're working on in Ontario West, where right now a family doc, because they don't know who's got the shortest wait time, will send the same request to 4 different hospitals. So 4 hospitals will book that same test, but patient goes to one of them and the other 3 are wasted slots, right? Or worse, they go to 2 of them. Not knowing it's the same request, right? So I think there's a lot of things we're going to look at using scheduling systems and AI to make sure we don't have duplication. But yeah, I think there is so we're not creating extra capacity, we're just using the slots we have now, but booking them in a smarter way, right? That's centered around what the patient can make as opposed to what bookings thinks they can make. Hope that's answered that question.
Thank you. Okay, any other questions for our keynote speaker? Just pop it in the question or pop it in the chat, or just put your hand up and you can ask the questions. Anything else to be asked?
Still waiting for somebody to say, yeah, nice. What were you talking about? what are you on about? And that's okay.
So I'll ask you, out of interest, the differences in jurisdictions between Canada, who's here, University of Costa Rica, so Costa Rica, and then Mexico is also here. We often discuss the challenges of the delivery of healthcare in different jurisdictions, for sure. And so my question to you would be, from what you know and from your experience, do you think AI could also contribute, so not only to what you're saying, which is completing the pipeline, right, for the care of a patient from start to finish, but do you think it can adapt to the different jurisdictions or help adapt to the different jurisdictions on how healthcare is being delivered? Is that a possibility, or do you see that as a possibility of assisting in those disparities?
100%. No matter which country you're in, we see the same access to health care transition depending on socioeconomic class, gender, immigration, et cetera, and language. So we see that. Now, maybe not all of the elements. Not every country has a family practice kind of guarding the gates. Some people go self-refer to specialists, right? So that algorithm still works as long as, you know, all those bits are in place. You don't need all those bits, but it's like Lego. You can take a bit out and just say, well, this bit here. I will tell you from the imaging point of view, 100% it works, right? Because if you look at patient body habitus, right, the way people look, there's different body habitus look at people in Japan, very different for people in the US, right? So when we have CTs that were made in Japan, so all of the algorithms we had to change, right? Because what they saw as a small patient and what they assumed was the shape of the patient is very different for North America, right? But that equipment is intelligent. You can program it in a different way. There's various ways of doing it. So, and that's the same. It'll be the same for Mexico. It'll be the same for. Sorry, did you say Puerto Rico?
Costa Rica.
Costa Rica. Sorry. Actually, I prefer Costa Rica. Beautiful country, beautiful people, lovely
Yeah,
coffee.
me too.
Don't like the volcanic sand so much, but that's okay. That's just a personal thing. But I love the country. Again, people, very different bills, right? So it's really important to know that if you're going to try to use the minimum amount of radiation, if it's a CT scanner, to get the max amount of information, you have to tailor it to that particular patient. And the other thing is, you know, whether that patient's with their arms by the side or the arms are out of the way, you have to tailor it for them, even for that same patient, from how they're positioned in the scanner. It makes a difference, up to 20% radiation, right? So I think there's a lot of tools out there now that can help us, that are already in play, and certainly they're adaptable to different jurisdictions and what have you. What I don't know is the legal piece, right? The regulations and stuff. And we know we have, even within different provinces in Canada, we have different regulations and different approaches. But it kind of has to be almost like the Geneva Convention, right? You kind of have to have a uniform declaration of, guys, these are fundamental things we need to put in place. But that only comes if you believe it's important, and if you believe it makes a difference. And so I think the biggest job we could do is to generate the data to say, you know what, healthcare is expensive. No country can continue affording what we're doing, continues to afford what we're doing now, because patients are getting older, multi-complex disease. But actually, if we're smarter about it, we could actually reduce the cost per case. We're not going to reduce total cost, but we can reduce the cost per case. And that's something the government are willing to listen to.
Awesome. And you know, you and I could talk for hours, but you know, you brought up another interesting point, especially for all the medical imaging or radiologists in the crowd, and that is you mentioned you know, modalities, and so right now there always has been a big push for much higher resolution, right? So MRI, ultrasound, for example, right now is still going to higher and higher resolution. But there's also a push for being able to diagnose with lower resolution. So low dose CT, you know, these MRIs that are, you know, you can carry around, right? So these, you know, low magnet, you know, MRIs, and an interpretation of, you know, POCUS, so point of care ultrasound, right? So my question to you is, which way should we be going? You know, higher resolution, lower, or both? What do you think?
Both. So both. So this is coming from someone who doesn't like to buy mid-range stuff. I'll just stay that up. But you know what? If you've got a fleet of, let's just say, 6 CT scanners or 4 CT scanners, do they all need to be top level? You need to have at least 2 that are top level, because if one is on service, you need another one. But you could actually, instead of having, say, make numbers up, if you had 4 top-end CTs, one choice, or you could have 2 top-end CTs and 4 additional CTs, so you could have 6 CTs. What would you choose? Well, the point is you choose the 6, right? Because for most of what you want, you need patients to be able to access, get in, get out, right? And for really high-end care, you could have the 2. And so I'm really keen on understanding the patient's healthcare journey and saying, what do we need as an early intervention, right? And it depends on what you're looking for. So I think there's a lot of use of the portable MRI. We've got one now, and we're sort of working with that. That's mainly for patients who don't have access to MRI. Either they're in the ICU and you can't unplug them, or they're out in a remote community and they don't have access, right? So something is better than nothing, as long as you don't make assumptions that what you've done is complete, right, for everything, right? You have to look at the major disease states and make sure you're addressing those. So I think we have to get smarter about what we're trying to do. So this is where the function comes in, right? What are we trying to achieve? What's the structure of that? In other words, I need to be able to get my wait list for CT down to, 5 days or whatever it happens to be. But the structure will be what kind of fleet can I afford? It has to have high end and low end units or mid range. I won't go low end, mid range units. And then, can we afford to do that? So I think there is definitely a need. I mean, for example, if you're doing intervention using CT, you're not going to use a high end unit. You don't need that, right? If you're trying to diagnose an abscess, so some things like that. So it's horses for courses. But that means you've got to work as a imaging leader. You've got to work with your administrative leadership to say, let's have a sensible approach to what we're putting here. You can't have, everything can't be high end, but you have to have enough of a cross section to meet the need. So in summary, both.
Well, thank you for that. I suspected you would say that, but that's wonderful. That's okay. So you know what? I think unless anybody has a last minute burning question, I think we're going to wrap it up here. Yeah, I think we're good. Thank you so much. What an excellent talk. Excellent question period. Appreciate you joining us today. And as always, it's a joy chatting with you. So thank you.
Yes, Pascal. I'm going to leave before Jeff Jaskolka disagrees with everything I've said. Right, so.
I'm sure there he's coming on.
I will say that I actually agree with almost everything you said, except for that you don't need good quality CT for intervention.
Oh, okay.
Apart from that, I was completely with you.
Well, when I say good quality, I use an 80 detector. I'm not talking about 4 detector. I'm talking you don't need a 320, but you do need.
And now I agree with exactly everything you said. I could not have agreed with you more.
Perfect. Thank you, mate. How you doing?
Good. Nice to see you, man.
You too, buddy. Take care. Have a great time, guys.
Excellent. Thank you, sir.
Cheers. Bye.
Okay, for the rest of us, we are going to be moving into our panel session. We have 4 minutes of break. So if you have if you need to take a bio break, please do. And in the time that you are, we're going to set up the panel. So thank you. Let's make sure our panelists are all here. Let me see. That's good. That's good. And okay, panelists. Indranil is here. Excellent. Giancarlo is here. Jeff is here. Roberto is here. So we need Chris. And we need Farzad. Let me just see if they're not here yet, I don't think. Okay, we'll wait another minute or so.
Yeah, my video seems to be giving me this strange thing rather than my camera. And
Yeah,
I don't know if it's on your
funny.
end or my end.
Yeah, Narinder had that problem too, but then it worked. So I'm not quite sure. Have you obviously, can you try like turning off your video? Oh, turn it on, kind of thing?
Yeah, so I did that. Like it seems like it's something on your end because I logged in with my
Oh, maybe. Okay.
I logged in with my personal registration email, not the presenter's email, because otherwise I showed up as presenter, not me.
Uh,
And my video worked before for some reason, so I don't really.
no, it seems chat's not
Right,
pretty.
I'll try to log out and log back in and see if my video comes
Yeah,
back.
give that a go. Okay, yeah, sure.
I'll be back.
Excellent. And Farzad has joined successfully. And you are, make sure you're part of the panel, Farzad. You are. Excellent. So that worked well. Farzad, which link did you use to sign in? The one you used to register or the one that I emailed? Or Indranil as well, actually. Just to help Jeff out. Because I'm not even sure who this is.
Sorry, Pascal, I was muted. So I used the link you sent today for panel,
Okay.
and
Okay,
but
that
I had
works.
to change my
No,
name
no, no.
because it
No,
showed presenter. So I just changed
No,
my
that's
name
fine.
here.
It's
Yeah.
fine. Don't worry about it.
So does it start at 2:30 or 2:45, the panel?
2:30.
Yeah?
Well, is there a
Okay.
break now? Sorry. Wait, you might be right, my friend. Let me
Because
just
I
double check.
think in the
No,
document,
oh, you're right. You're right. Oh my God, we have a break.
yeah. Okay.
Oh my God, you're right. Thank you for pointing that out, Farzad.
Yeah.
So, woo, good. That gives us time. So for my apologies to the gang. You guys get a little extra break. You get a time. You get lots of time for your bio break. So please make sure you come back 5 minutes early. Okay. So come back at 2:40. So let's give us 10 minutes. You get a break, but please come back. Stay logged on. And then you can come back in about 10 minutes, okay? So thanks, Farzad. I totally missed that. That's excellent. All righty. Excuse me. Getting ready. Let's see. Chris is here. Farzad is here. Fantastic. Hamza is up there, but he shouldn't be. So let me fix that. There we go. Indranil is here. Excellent. Roberto is here. Fantastic. Carlo is here. Let's see. Nushin is here, but she's not on the panel. So let me fix that. Okay, I'm just gonna move Nushin off. There we go. We have someone who's presenter. Who is that? Not sure who that is. Farzad, Chris, Indranil, Roberto, Giancarlo. Isn't that everybody? Then we have these two presenters. I'm not sure who these are. I think, you know what I think it is when you guys logged in, there might have been like a dupe or something like that. So it doesn't really matter. Let's just leave it as is. Oops, I didn't mean to do that. There we go. All right. Are we back? I think most people are back. That's good. Bio break is done. We got another minute. Sorry, guys. Let's give it another minute. Give people the chance to come back. Thank you very much for joining. That's fantastic. We'll get started. I'll just remind you guys of the rules. There aren't any. So I'll be asking questions. You answer when you want. If we get sidetracked and we go down rabbit holes, I might pull you out. But other than that, feel free to answer. Keep your answers concise if you can, just so we can get through more of the questions. And I will direct to people, but if you want somebody else to speak or if you don't have an answer, just say the word and we'll move on. So we'll do that. All right. It is 2:45. Let's keep on schedule. I think everyone's back. Let me look at my. We're down a few people, so they'll trickle in, I guess, as we speak, which is fantastic. So here's our plan. We are now at the panel session. I'm just looking at my schedule to make sure I've got everything right. Yeah, medical imaging for all. That is now. So we'll start off by welcoming our final panel. So thank you very much for the medical imaging for all. Now, we've spent today discussing the potential of AI, so that's what we're going to talk about a little bit more, from image to impact. We just had a great keynote from Narinder Paul on the roadmap for creating, testing, ethical, and implementing ethical AI. And in this panel, what we're hoping is we take the idea and tackle the most critical and most difficult part, which is, how do we make that potential a reality for everyone? And that's the tricky bit. How do we get these tools to be shared with all? We're going to focus on revolutionizing access, if we can, using AI, and looking at or expressing real world barriers to the global deployment of AI. Opportunities in mobile and low cost innovation, I hope, will be a topic that's brought up. And then, of course, the ability to build sustainable and equitable imaging ecosystems is also something that hopefully we can talk. Now, we have obviously an outstanding group of experts to tackle this. I'll just ask you guys briefly to introduce yourselves to the panel. A couple of sentences about who you are, what you're doing, and why you're on this panel would be great. And I will. Well, Jeff just popped into the center, so why don't I start with Jeff? Jeff, so just a quick introduction, and then we'll go to the next. Thank you.
Sure. So I'm Jeff Jaskolka. I'm a diagnostic and interventional radiologist working at a community hospital outside Toronto. I have a long-standing and deep interest in AI, and especially actually in the non-image interpretation aspects of AI and how they can be implemented sort of relatively sooner and easier than full automated medical imaging reporting versions of AI that we're talking about. Apart from that, I'm not really sure why I'm on this panel, except for that I somehow know Pascal, but I'm very pleased to be invited, and thank you for allowing me to participate.
You're very welcome. Very humble. I like that, Jeff. We're going to go to Farzad. Farzad's next on my squares.
Yes, hi. My name is Farzad Kalvati. I am Director of Radiology AI and Senior Scientist at SickKids and Associate Professor at University of Toronto. Very happy to be here, and thanks for the invite.
Once again, very welcome. Next in the squares is Chris.
Perfect. Thank you. Hi, I'm Chris McIntosh. I am a scientist at UHN and one of the fellow AI chairs with Farzad in medical imaging at U of T. My research area is in computer vision, machine learning, medical imaging, and in healthcare. So delighted to be here. Thank you.
You're welcome, of course. Next on my squares is Indranil.
Thank you for having me, Dr. Tyrell. I'm one of the chief radiology residents at Western. I completed my medical school and statistics degree at U of T and had the privilege of being part of Dr. Tyrell's lab for the last 11 years or so. I worked on various projects, learned from a lot of people. So hopefully I can share and regurgitate some of the various things that I've learned from everyone here, actually.
Thank you, Indranil. Yes, I was going to say I probably had more hair when you first met me, but I don't think I did, actually, sadly. Okay, next is Giancarlo.
Hi, everyone. Well, my name is Giancarlo Segura. I am a medical doctor from Costa Rica. Right now, I'm the director of the Department of Medical Integration, that is for AI and Simulation Health Center. Well, also I am been working in the communities outside from the capital here in Costa Rica. So nice to meet you, and it's a pleasure to be here. Thanks.
Thank you, sir, and thank you for being here. And last but not least, we have Roberto from Mexico.
Hello, my name is Roberto Rosas. I am professor at Universidad de las Américas Puebla, UDLAP, at the Department of Computer and Electrical Engineering. In the last years, I've been collaborating with the students and faculty on analysis of medical imaging. Thank you for the invitation.
You're very welcome, and let's get started. I didn't miss anybody, right? No, excellent. So we're gonna get on the first question to you guys, the on the ground problem. So we're gonna start with a list of challenges. We often develop AI in the perfect, pristine, high resource lab condition, and then when we talk about global deployment, what is the single or maybe if you have a few, most underestimated infrastructure or systems barrier that can cause a fantastic AI tool to fail in the real world. And so we can start actually, because Roberto is on the screen. When we start with you, you have hands-on experience implementing technology in rural communities. So in your experience, what's the main hurdle that you've come across? Maybe internet or hardware, or please let us know in your opinion and from your experience.
Okay, one of them is one challenge, one problem is that you train these systems using a data set, but that data set is constrained. It only it's about just one specific population, but you need more information to make it global or to go to isolated populations. So the problem partially solves the problem in the case of helping diagnosis. That is one challenge. Another will be that if you have an application running on a clinic, the people there has to receive some training to understand what they have, and also and also to give it maintenance for the future. And I think those are the main problems, and maybe storage, also storage, because these applications, the images that are used, okay, have to be stored in some place, but there has to be also a central place. So, but who is going to do that? That is, those are the challenges.
Mm-hmm. Thank you. Like Giancarlo in Costa Rica, so you're only a little more south than Roberto.
Yeah.
Do you have this similar challenges that he's just described, or do you have different ones, or?
Well, yeah, that's a great question because when we are thinking about AI, people is thinking about computer systems, whatever. But well, that tool is for people. So one of the challenges that we face here in Costa Rica is culture, especially when you are going outside from the capital, from San Jose. People in rural areas don't have enough services to access to these technologies, and also they don't believe it or don't adapt to their culture. So I will say culture, for example, and also, as Roberto said, infrastructure, right? There are some areas, especially here, there are huge forests, totally rural, that probably access to internet is difficult. So probably this kind of technology has to be adapted to that community, or maybe will fail because they will not have the same results as in the lab.
Yeah, thank you. Yeah, Giancarlo and I have this discussion often when I'm working with him in Costa Rica. So Chris, I'll ask you because I know you've have multiple projects, and so I'll ask you in the same context. What do academics get wrong? About this non-technical side of the deployment. Things like, in your experience, maybe partnerships or regulatory or business models or something like that instead of the classic technical problems. What have you bumped up against?
No, that's a good question. So I agree with a lot of the comments said. I think the infrastructure changes a lot. And so it becomes a technical problem in what we call like out of domain distribution, where the imaging acquired, for example, In a developing country, they have different electricity, different power patterns, etc. So they have different noise signals into the data, but we don't think of it as a technical requirement, if that makes sense. Like our technical requirement is to deploy this, you need an X-ray scanner. We don't think of you need an X-ray scanner that runs exactly like the one at my hospital, because that's what I trained my model on, and now I'm going to deploy it to you, and it's going to drop from 90% accuracy to 60% accuracy, etc., because the images don't look quite the same. And so like it's a kind of an infrastructure problem that creates a hidden technical requirement, if that makes sense.
Yeah, yeah, definitely. And so I'll open it up to the rest of the panelists if you want to contribute something in your experience or what you've bumped up against in deploying, or it doesn't even have to be necessarily the end deployment, right? But it could even just be the next step, right? So meaning when you go from theoretical in the lab, you go through multiple steps until you actually deploy it and you're using it, either clinically or in the field or whatever. There are multiple steps that get you there. So in your experience, is there anything that you've bumped up against in the deployment that you'd like to mention? And so Jeff has his hand up. Absolutely. Go ahead, Jeff. What happened to Jeff? Oh, there he is. No, you're muted, sir.
Sorry. Such a rookie mistake. So yeah, what I was saying is, I work in Toronto, which is a pretty big city, and I'm not too far from the academic places where these models are being developed. But like in terms of being able to actually deploy a model, sometimes I feel like I'm in Costa Rica because, like you said, there's a whole issue about the model integrity and does the data match and how does the model perform. But even if you set that aside and assume that you have a model that's going to work beautifully in your environment, like the nuts and bolts of getting one of these things installed is actually quite complicated because, for example, first question is, are you going to run the model on premises or in the cloud? Because if you're going to run the model on premises, then you need to have hardware in your hospital that is capable as some sort of GPU. And no matter what you're doing, your standard hospital setup is not going to have a GPU server rack. So the first question is, where am I going to do the computation? Again, assuming an adequate model, where am I going to do the computation? And if that means, in addition to whatever the cost of your model is, there's a cost of, am I buying servers that can run this in the hospital? Or am I running this in the cloud? In which case, then I have the privacy and security issues that can be as much of a barrier as the hardware procurement as anything else. So I think it's something that is one of the reasons that 80% of all models never get off the person's laptop where they're developed is because it's not just quality of the model, it's how are you going to get it running somewhere. And that's got to be 10 times as hard in rural Costa Rica where there may not be the infrastructure or the power to run the model. So I just want to highlight that as something I've known about and now I'm experiencing firsthand.
Yeah, definitely. That is absolutely something that we bump up against all the time. Farzad, please.
Yeah, I agree with everything that was said. I was thinking that for some of the solutions, not for too complicated ones, but some easier cases such as, let's say, detection based on X-ray, I think eventually we need to think about, some sort of universal models that can be hosted somewhere. And people from, remote areas, if they only have access to internet and let's say X-ray machine, they can just send their images and get the results back. So that way we might be able to solve the infrastructure problem on the remote areas, and also it would provide the opportunity of collecting a diverse set of images to keep improving the model. But the idea of having this a server-based service open to anyone in the world to send their images, I think that has not been really thought of well enough.
Well, I think if any of the large providers are listening to your comment, they're going to agree with you wholeheartedly. So in terms of, the Google and the OpenAI and the Microsoft, I mean, I would expect that is their plan. So I know what you're saying is, of course, you want it to be open and accessible to everybody. But actually, I think many of the large providers are actually thinking that that's what they would like to do, is to provide a one-stop in the cloud, shop in the cloud access, and then of course leverage the data that's coming in as well. And so that's an interesting concept, right? So what you say is absolutely true. I agree. And then on the flip side, though, how do you do it equitably, right? So that's the tricky bit, is the trust and equity. And so Farzad, I couldn't thank you enough for the transition to the next question. So that's absolutely perfect. And that is, yeah, so that it does kind of bring, into light this theme of, when you're building local capacity, how do you do it using responsible AI, right? And so, a model trained on different populations may not be generalizable to all populations, of course. How do we build in the trust and the validity of these tools locally? So, I mean, that's the other piece, right? So you can have this big brother almost thing, where you have everything central, everything's cool. But how do you build that so that you have local trust, right? So, and that's going to be, the challenge. And so I can ask you actually, yourself, in terms of what would you see, or how could you address that with technical solutions in order to mitigate that? What would you say to that?
Right. First, I don't really think that it has to be the big guys, the big companies doing this, right? I mean, any research center like ours can host, I mean, may not be that scalable, but it's still to reasonable scale. So let's say we have an algorithm, we have validated, and we can really put on a cloud-based server and give access to everyone. So that's one point I wanted to make. So it doesn't have to necessarily be Google or OpenAI. The other side is, I think we should look at the issues, in terms of priority. I think the first priority is to provide care, or for the people to receive care. The next one is the local trust, or do we have enough local data to fine-tune our model, to work perfectly for the local population. If I am in a remote area and this cloud-based service would give me immediate access to the initial diagnosis, I think that's really a great step. And okay, the next step would be, do we have capacity to collect our own data locally, and then, as you said, customize the model to exact characteristics of our own population. So the second the second topic should not prevent us from providing the immediate access to care in the first place.
Yeah. Nice comment. And of course I agree. It will be tricky on the balance on that, but yeah, I completely agree. So Indranil, I'll ask you as a resident, because you're the up and coming, right? So you're the future, and you're living, this AI implementation, and you're training to be the clinical end user. What would you require, or what would you see you need in order to trust this AI or algorithm, if it wasn't trained where you are, right? So this local validation. So what are you looking for?
Yeah, that's a great question. I have a few points, but before that, I'll just mention, because we're talking about global and local. Nowadays, they call it a glocal. It's kind of like what KFC did to succeed in China, or like McDonald's did to succeed in India. How do you have the power of big data but still adapt to local taste? That's the big question, I guess. But to answer your question, yeah, local validation is important for sure. Practical example, like in another place, a study that you might have reflexively called TB would have a very different differential diagnosis here in North America. So there's definitely practical aspects of it. From personal experience and polling some of like the breast radiology staff around here, I've noticed that the CAD systems are very sensitive, calling stuff that you wouldn't really work up. The breast surgeons here in general are, prefer specificity over sensitivity. So point being that algorithms have to have some sense of local taste to sensitivity and specificity of calling things. And then finally, I won't take the name, but we recently implemented a new AI software here in London for detecting stroke and hemorrhage. And 2 years out, the report is almost universally ignored. Most people don't trust it. The neurologists always call us for reads anyway. It kind of just takes time. But I think the reason it was ineffective, of course, is because it wasn't trained here, because of scan quality or type of scanner differences. Maybe that's why. But a very good metric for effectiveness is the trust that it fosters, in which case, something that this model didn't have. So for sure, local training is very effective for good implementation.
Okay, wow. So again, the audience is going to think that we actually practice and train this, but we really didn't. But in general, that was a perfect segue. And the reason I'm going to say that is because Giancarlo and I are working in Costa Rica on exactly that. So implementing AI. So in our case, it's for mammography. And that's the challenge, right? Is what you said. So the example of what you said, that you're getting these reports and people are just basically ignoring them. And as you said, it could be because it's not locally trained and it's not on the same machines and all that stuff. And so, Giancarlo, I'll ask you to comment on that in terms of what we're doing in Costa Rica, in terms of how you think we're going to be successful with, retraining, with Costa Rican data and all that for the mammography project.
Well, yeah, we have a project here with the public health system, and it's a combination also with the universities to create this tool to help to have a kind of triage about the results of the mammographies. So as Pascal said, it's so important to have the data. So we are trying to have like from different hospitals the information to create this process of external validation, especially for us. And well, during this process, it's important to incorporate some kind of physicians and also part of the administration of the system, because if not, they will not trust us. Do you know? This is part also that people have to believe us. It's not just to say like, hey, we have these numbers, it's perfect, this kind of algorithm. It's also that they believe the process in which was created, and that take us time. And that is also so important, because if I told you I would like that in short time we have all the information, but if you create kind of interinstitutions, interdisciplinary team, there are more opinions, there are a lot of people, so maybe that will take time to get all of them in the same path. So I will say that to be successful, you have to include all the institutions that are obviously part of, and also all kind of physicians, technology, administration, and different areas to create this AI tool.
Yeah, completely agree, especially on the buy-in, what we call buy-in, which means that, the people that are the users, that people that are going to adopt the software have to feel like they were part of the process, or at least their institution or their friend, somebody that they can feel, oh, wow, I relate to that because that's homegrown. It's like with us. So even if it's retraining, so if you're taking an algorithm that's coming from outside, but it was retrained and validated with the administration, with the physicians, with the healthcare system that's local, it definitely is, I'm not going to say it's perfect, but it's going to definitely assist in adoption for sure. So that's great. Does anybody else on the panel have anything they want to add?
I would just say that's something we need to build into the mindset, like of how these things are going to be deployed, because I think there's an expectation amongst people that you're going to buy Rapid AI. Not that I think that's the software product that you bought, that you're going to buy Rapid AI and turn on in your hospital. But I think that people need to understand that you buy it, you have to have people in your institution who are going to validate it and or fine tune it if the company you buy it from will let you do that. Like, it's partly it's the mindset. I think people aren't used to the idea that you have to buy software and then do something with it before you turn it on.
Yeah, yeah, absolutely. I think you're right. I think it's different, right? In terms of and actually, this is a little bit of a sidebar, but what's interesting as well is once you've bought it and once you've implemented it, we're going to actually have to track bias, right? Or shift, right? And that's something that needs to be put into the system, right? The administration. So there needs to be like a committee that's struck within each institution to monitor and manage all AI software in that institution so that regularly, let's say annually, everybody meets and says, okay, hey, how's the software, working? Do we need to retrain in order to avoid that bias creeping in because of various changes, right? Whether the disease is changing, the population is changing, the tech is changing, the scanners are changing. And so that's very different, right? Because that doesn't exist today for, just standard software that we have deployed. So yeah, Giancarlo, you have your hand up.
Yeah, just a comment in that way, in that also in that area is for me it's like kind of humanize the AI process, because if you create a committee, obviously there is the algorithm, but that committee is the one that is taking decisions. You have a face-to-face to know in which people you can trust, in which people you can have the time, the space to make some questions if something is going not so well during the process. So if you humanize that project, probably you will be more successful.
Yeah, agreed. Oh, Roberto, please.
Yes, I would like also to mention this. Usually, when using artificial intelligence to apply to some medical problems, we are using third generation or second generation artificial intelligence neural networks, and that those are difficult to explain and to understand to have a clinical understanding. But for example, there are problems that can be solved by using first generation artificial intelligence that is basically based on logic to take decisions, if then statements. And when using that technology, that first generation tools, it's easier to to have a communication with clinicians, with physicians, and they are in. It's easier to trust on those tools.
That's wow. That's an interesting comment. I like that. And that is, how would you say that? No point in making it more complex than it needs to be. And you're right. If you can, and that's something that is coming up now, and that's explainable AI, right? So the ability to have interpretable or explainable AI is very important. And so I agree with you, Roberto. I think actually many of the solutions may actually will look to implement solutions that are exactly as you say, more simplistic or logic based solutions, which will then be easier to meet the explainable and interpretable aspect of the deployment of AI. So that's an excellent comment. Yeah, I like that. We can kind of push through now into the next question, which is going to be workflow and value, right? So where's the value in this, right? And so Jeff's already mentioned it a few times, but he's an interventional radiologist, and in terms of reporting and in radiology, and you and I have had this discussion a few times actually. What would be in your opinion what the low hanging fruit is in this situation? Where we can just build on what we already have in terms of quality improvement and research. Like so, what would you see as like low hanging fruit for AI right now?
Yeah.
Your
So as
role.
I said
Your role.
before, yeah. So as I said before, I'm biased towards some of the non-interpretive potential for AI, and I think our very first speaker said it so beautifully, which is that like the AI and the LLMs have the opportunity to unlock all this data that's already existing in our system. So there are enormous amounts of data that exist in any hospital's EMR that could be used both for improving patient care and or for scraping for data to do research. And I think that's a low hanging fruit for sure. I think it's I think it could, advance the speed at which research projects are done. And also in a certain way, like it's like if you have an AI application that summarizes the medical record, but then a human still has to act on it, it is a lower risk human in the loop approach to applying it rather than putting AI into actually doing the image interpretation where a lot of resources are being spent. So I think there's a lot of low hanging fruit there in data collection and aggregation, and also in workflow orchestration for the same reasons, like uh scheduling, AI for scheduling, fine, like at the end of the day, like it's a low stakes thing. So if it gets the schedule wrong, no big deal, because at the end of the day, a human has to push the button and do the scan. And so you have opportunities to put it in place in that kind of environment where there is intrinsically human in the loop.
Yeah. I mean, that's a great comment on the scheduling. I think that's actually, I know at Unity Health, Mohammed Mamdani has been working on a lot of that. And it's amazing the time it takes for scheduling, especially nursing. Like the time it takes to figure out who's going to be where, when, and how, and who's available and who's not is just a daily task that takes a lot of time. And wow, absolutely, as you say, AI can definitely assist in that. And then at the end of the day, it's going to be checked, validated by whoever shows up, right? The nursing that shows up. Far as that, yeah. Comment.
Yeah, I completely agree that AI can also be applied to interpreting tasks, such as scheduling. I just wanted to mention that actually we did a project on scheduling of patients at Sick Kids Hospital on the in the imaging department. And the goal was to find or predict patients who will miss their appointments. And so we did that part. So we can actually predict with really reasonable accuracy, close to 90%, who will miss the appointment and also who will have to wait a long time once they arrive. So that part may not be that complicated, but the main goal is that, okay, can we reschedule them so we minimize the chances of them missing the appointment? So we first want to identify those patients and then reschedule them such that this time, with the new appointment time, hopefully they will not miss the appointment. And you can just imagine that this can have really multiple impacts in terms of usually the patients who miss their appointments, they come from a different socioeconomic status. So this would definitely help them, or this would definitely improve equitable access to healthcare. And the other side is, of course, optimal usage of our resources in the hospital.
That's an interesting concept. I like that actually. So not only you're going to predict whether a patient and their family, let's say it's a kids, of course, are going to miss an appointment or not show up, right? But then you're going to automatically reschedule them, to some time that's better for them. So inevitably, you could also move that forward, right? And just when they initially book them for when, exactly as you say, book them for when it would be most appropriate for them to not miss the appointment. That's great. I love that. That's fantastic. Yeah, Jeff.
I'm going to try to stop talking so much now, but the other thing I wanted to say about this, about these non-interpretive things is, there's sometimes an ROI for that, in the sense, so like when this is a very pragmatic thing to say, but like if you're talking about getting a stroke detection software into a big healthcare system, like there's no ROI, because basically the hospital pays for an improved outcome that's almost impossible to measure and makes the radiologist's lives a bit easier, which the hospital doesn't care about. Whereas if you do stuff like preventing missed appointments or decreasing clerical overhead or improve scheduling, like then the hospital can say, oh, by implementing Farzad software, we've decreased the number of no-shows and therefore increased our capacity. And that is an ROI that can be measured and that they like. So, okay, now I'm going to stop talking for a while, but thank you all for listening.
No, that's an excellent comment. Very pragmatic, because you're absolutely right. And that's a challenge, everywhere, in the sense that if you do anything that doesn't impact the bottom line of an institution, it's great. Obviously it's fantastic to improve the health of your population, but as an institution, it's not as impactful to the bottom line, which is what drives the institution, which is great. And so that's where we definitely need, to have, the link between the institution and the government, right? In that sense, to anyway. But that's a whole other topic. But that's fantastic to bring that up, for sure. So I just to not devil's advocate. I don't think it's that much, but for Indranil, I'll ask Indranil. Because you're right in there, and you already brought this up. What would be the difference between a tool that you see as usable, right? Or one that ends up being an interruption, because that is a common, I have this discussion with residents all the time, and fellows for that matter, in terms of different software and different approaches and different, new ways of doing things. Sometimes they're really helpful, right? Sometimes they're really great, but then other times, yeah, it's disruptive, and it's not as useful as you thought it would be. So what do you say to that?
Yeah, it's funny because I have a very cute example of this. Dr. Bill Billiard, I'm not sure if he's still in this in the meeting, but in 2023, he had a little fun competition at one of the radiology conferences where he sort of displayed one of his AI tools for osteoporosis detection. Yeah, we were lucky to win that. I was really excited to bring it to Western. I used to hound Dr. Paul every couple months to ask, when's it going to be implemented? It's 2 years out, it hasn't been implemented. And then at some point, he finally sat me down and he told me, okay, look, the reason it's not implemented is because if this catches more osteoporosis, these guys are going to need more BMDs, but we don't have enough BMD machines in the city to accommodate for that. And then on top of that, they'll need more rheumatology referrals, and the rheumatologists are not willing. There's not enough, basically. So there's all of these logistical things which I had no idea about behind the scenes that were kind of holding things back. Second, sort of like quick, because Dr. Jaskolka mentioned like low-hanging fruit for radiology. One of these things is also like natural language processing. So I had the idea of just looking at patient or like histories that referring doctors would provide, and then going from that to the protocol, like what type of scan do you need? For example, if you came in with a headache, do you need an MRI or do you need a CT? And it's very easy to say like, yeah, you need an MRI, but that's not always possible because of the resource constraints that are in place. So point being, for that project, we very quickly realized that the best way to train the model was to go on existing protocols that existed in the city and the huge database available there. And all is to, I guess my long-winded way of saying that for ML models to be usable, the community has to be ready for all of the next steps and actions that they would sort of generate.
Yeah, that's a great example, and it's too bad Narinder had to go back to another meeting. We could have put him on the spot for that. But it's a very good point, and that's actually comes up all the time, and that's capacity, right? So what are you capable to do, and if you open that door, what do you deal with downstream, right? So what an excellent example. That's fantastic. That also brings into play what type of software you're thinking of, and so the difference between like an assistive software, so for instance in radiology it'd be like contouring, right, or something like that, versus a new diagnostic, right? So the ability to diagnose. And so I know Chris has put out some solutions, and so I'll ask him, which one's easier to deploy, like an assistive software or something that's more diagnostic?
I mean, I think anything that keeps the human in the loop is obviously much easier to get through FDA, etc. So I think that's easier from a kind of just a high level perspective. But I think, to some of the points made earlier around efficiencies in the workflow, I think that things that actually can save very large amounts of time. And so we deployed some radiotherapy planning AI-based tools 2019. They're FDA Health Canada approved. They're used all over the world. But I think the reason that they got adoption is because we took something that was like 3 or 4 hours down to like 10 minutes. And so there was a lot of room for the AI to be kind of wrong, and you could go in and fix it and you'd still save a lot of time. But when we're talking about things that are often like, a quick yes or no patient diagnostic, like yes or no patient has XY, when the AI is wrong, the physician it takes them just as long to look at it as they were going to originally. And so the time saving gap can be very, very low. The frustration burden, like we heard earlier, all of these reports were stroke that, the AI generates and humans don't read. Well, it takes 3 minutes to read the report. It takes 3 minutes to look at the scan. What do I prefer doing? I just might as well look at the scan, right? So I think, yeah, it's not so much diagnostic versus prognostic. It's kind of eliminate time-consuming things.
Yeah, I like that. That's a great comment when you say, where would you prefer to spend your time? It's an interesting comment, right? In terms of what would I rather do, and then how's that, what tool do we need to develop in order to help you at that level? That's a great, yeah, that's a great comment because yeah, that's true. It's true, and that's where preferences come in, and as developers, as researchers, sometimes we don't think of that, right? Which is interesting because we always think, oh yeah, obviously, we need the software to do this. And then you bring it to the people in the field who actually are going to use it. And nah, that's really not, that's no thanks, that's not what I need. And so it's interesting that it's always very important to consult with the users for sure. So our last question, we're basically on time. The last question here is, I'm going to open it up to everybody, and that is, what are your thoughts on low-cost innovation? So AI producing, supporting low-cost innovation, right? So, for example, some of the work I do is mHealth, so mobile health. So inevitably, the use of your phone is, not everyone, but most people in the world have phones, and so there's a conduit, right, to deploy AI. And so my question to you guys are, in your opinion and in your experience, what would you think would be, maybe again, low-hanging fruit for AI to, generate low-cost innovation in healthcare? Go ahead, anybody, jump in there. I know Roberto has done deployed some low-cost tools in Mexico, for sure. Giancarlo has a little bit. Let me know. What do you guys think? Not all at once. Roberto, go ahead.
Roberto wants to get in here.
Yes, there are some many applications very interesting by using cell phone. For example, one is falls. Falls is accidents, people falling. And for example, the cell phone has some tools, gyrometer, that can be used to detect falls. So an alarm is sent to a place to assist that person that just fell down. And for example, that is a good application by using cell phone. But there are some applications that are more difficult for the implementation in cell phones, because the cell phone, even though it's very fast, it has a lot of potential. Some applications cannot be taken from a laptop to a cell phone. The cell phone is still very constrained in terms of storage capacity and processing speed.
Thank you. Yeah,
Yeah.
I obviously couldn't agree more. Giancarlo, yes.
Yeah, Pascal, just to say about our experience here with indigenous communities, I will say minimalistic, right? Like trying to have something that can be called as small, but maybe can fix a huge problem, right? So just to give you like an example, we have the idea here to create an app for traditional medicine. And well, we were created a plan identifier with AI, with a camera, with a cell phone and all that, with a smartphone and all that, offline, because probably they will not have access to the internet. But then, just for fun, you put like a dictionary of their originary language, and they really love it. And that happens because there is a huge problem right now about the youngest people that they don't want to learn about this kind of culture information and obviously all this cultural heritage. So the leaders look at this and they say, wow, we really love it. Maybe that is like the first step just to start. Well, at my first comment, right? That you have to create kind of trust for cultural interventions because you are doing that with AI. So I will say that just to get successful, maybe you don't have to create a huge gorgeous algorithm. You have to start to talk to people, look their problems, and maybe try to find how these kind of AI tools match to help them with that problems.
Yeah, I mean, yes, of course. For those of you who don't know, Giancarlo and I have put together a project in Costa Rica called Pura. It's an app, and as he said, the intent was traditional medicine, and then we just, as an add-in, we threw in this dictionary, and then that's what got the attention. And so you're absolutely right. And I think what that comes down to, and this could be a whole other conference, and that is implementation research, right? So how do you actually implement something that you have developed in the lab is a whole area of research, and it's very tricky. And it's interesting that it's implementation research is nothing new, right? It's been around forever. But I think AI is kind of pushing the boundaries of it very quickly because of its utility, right? So the perceived utility of AI is immense, right? And so there's more of this thought of implementing AI all over the world, and so then it's kind of bumped up against this, and we're realizing now how important it is to incorporate the concepts of implementation research within AI research. So yeah, no, thank you for that comment, Giancarlo. Absolutely. Any other comments from the panelists? If not, I'm going to open it up for questions to the audience. Any last comments? No? Okay. So on that note, thank you very much to the panelists. Fantastic. We now have the opportunity to take questions. So you can either put it in the chat, you can put it in the question section, or you can just put your hand up and I will let you ask the question out loud. So does anybody have a question for our wonderful panelists? I know we're coming kind of to the end of the conference, so people are probably looking to, Anybody questions? Let me see on the chat. Nobody on the chat? No? It's a quiet group. It's a quiet group. Nobody so far, right? But I'll give the opportunity. So in reverse, I'm going to give the panelists the opportunity to ask something of us. Does anybody in the panel have a comment, a question, just out there, that they would like to ask or state or whatever? Anything? Just why not? Throw it out there. Get the juices flowing for the audience. Feel free. Just jump in. Just say something.
I have a question. Farzad.
Go ahead. Sorry. Go
do
ahead.
it.
No, you first, Farzad. I've spoken enough.
No, I would just, this was a comment and a question. I mean, this data governance and data ownership is different from jurisdiction to jurisdiction. And I think that's one area that will impact how AI is developed in near future. So I was wondering what your thoughts are that how it should be, who should own the data? Is it the patient? Is it the hospital? Is it the government? And because if we solve this in a way that everyone is happy, I think that would really help with the democratization of access to data for generating or creating, AI algorithms in general.
Wow. So that is a big can of worms on that one. data ownership is a tricky one for sure. I mean, inherently the data is owned by the patient, but you're right. Depending on the jurisdiction, that ownership is shared, right? Wow, excellent question. And each jurisdiction, deals with it differently. But yeah, and I've worked in a bunch of jurisdictions, and it really is different in each one. And even like for instance, the United States, a lot of the ownership of data is shared, especially under the insurance umbrella. That patients they forcibly to be part of their insurance are sharing their data. So, very interesting comment. Yeah, I don't know where that's going. I I'm going to say just from personal reflection, I have a feeling that, each jurisdiction is going to massage that relationship depending on how much they need the data. You know what I mean? Like I have a feeling that's the way it's going to be. If you're a jurisdiction that really needs that data in order to do the training and get the algorithm, then they're going to apply pressure, right, to have that data shared, as opposed to if we're privileged, for instance, in Canada or United States, then maybe not as much, right? Because you're like, well, nah, don't touch my data, and you don't really need to because we're privileged. So, wow, great comment. Just to we do have a bunch of questions now. So let me start with Nabia. So she's been asking, he's been asking questions earlier a lot, a little bit more broad, but as a pre-medical student hoping to get involved with AI in medicine, would you have any tips on getting further involved with the field? Anybody, feel free to answer.
I don't know where Nabiha is from, but if they're from U of T, I think the man to look out for is sitting with us right now, Dr. Tyrell. So uh, if they can reach out, that's how it started for me. But jokes apart, I think it's very hard to come up with something on your own if you don't know the infrastructure that you're getting involved in. So any sort of finding any mentor, or there's so much AI research these days, finding anything you could tag along to initially to get your feet wet, and then going in deeper is probably the best way, because there's so much literature and self-learning that's possible these days. It's easy to go deep, but finding that start is the hardest part, which hopefully you can find someone to help you get there.
Thank you, Indrano. Any other comments on that one? I agree. I mean, it's a start, right? You have to find a start. What works for you, and once you're on that path, then it's just navigating that path and what can you do in order to improve. Going to what more AI, less AI, or what kind of AI you're interested in. So Hamza has a question as well. Thank you all for this impactful panel. Question for Indranil. Do you see any new applications in body for AI that would help in residency/fellowship training? Or when it comes to guiding biopsies or auto measuring organs, nodes, tumors, etc. in imaging? Wow, very specific question. I love it.
You might know things that I don't, it sounds like. But I think learning initially anatomy is always the toughest part. I don't know if Dr. Jaskolka has any experience or seen something like this before, but it'd be really cool to have something point out anatomy for you early on in your training to help ease that learning process. I don't know if something like that exists.
So, I mean, there are non-AI tools that do some of this that are really great, actually. But I think one really interesting and promising angle there's a thing called MedSegmenter, which is basically an open source public project where they basically gathered I don't know how many scans and basically manually labeled them. And now there's you can basically, I think it's an open source model. You can basically get it to segment your images for you and show you the stuff. So that's interesting. On the IR side, it's also really interesting area of prospect, but not a lot of sort of completed development. So there's lots of sort of AI guided fusion or image fusion that's not AI guided, where you look at an MR and you can kind of fuse that on a CT or an X on a fluoroscopy view. And there are some tools for robotic guidance, but it hasn't all yet been integrated where you just sort of say, here's that thing I want to biopsy, and then press go, and everything is kind of robotically aligned to do the biopsy. So it's more low level stuff so far.
Yeah. That's an interesting comment that there is fantastic software out there for segmentation. I've seen that. I've worked with that as well, especially for neural. And it is great. It is great. And so, yeah, wow. For sure. We have a question here. I'd like to know more about the Costa Rica project. Was there a reason that geography was selected? So I can just answer that one quickly. It was opportunity, right? So, it just turned out I ended up going down to Costa Rica for one of my startups, and I met the right people, and that was the start, and that's the reason that we did the project there. So it's as easy as that. And so that comes to Indranil's comment is, where do you start? What's the opportunity, right? And that's what it was. And so I was lucky enough to meet Giancarlo, fantastic in Costa Rica. And that's how we got started on the project. And Giancarlo works very closely with indigenous communities as a physician in Costa Rica. So that's how it got started. So.
Yeah, but Pascal, just to add that we have a project here for more than 10 years. So we get involved with all these communities. So we found a problem in that moment, and so the opportunity appears. And well, we are after all this time.
Literally. So we have a question from a good friend and known radiologist, Alex Bilbili. And so he says, he's asking the panelists, he's putting you guys on the hot seat. From the perspective of maximizing impact of a newly introduced AI solution, could any of the panelists speak to the value of training, educating users and downstream clinicians, patients that might be impacted by the use of this tool? It probably depends on the exact use case, but wondering if any of the panelists have seen success in investing in this kind of educational initiative alongside introducing a new tool, or if they have tried training initiatives with minimal yields. Oof. Good question. Excellent question. And I completely agree, by the way. That's great. Yeah. Coupling the education is key. It's got to be. But what do you guys say? Anybody in the on the panel have any experience in terms of deploying and seeing the value of deploying with training and education? Yeah, it's it's a tough one. I think it actually already exists. Of course, it already existed before. So any implementation of any complex software, the uptake, the adoption, the use, the success of the software is always enhanced when you get training, right? Inevitably. And so a good example of that is Epic. So the hospital system, Epic, which if in Mexico and Costa Rica you're not accustomed to it, it's the largest hospital patient chart system that is here in North America, and it is unbelievably complex, and it takes literally to deploy it and use it. It takes years to train the staff and whatnot. So inevitably, it would not be successful if it wasn't coupled with training. But does anybody else have any other comments on that one? Who's gone through the Epic training? I know as far as that. So I mean, I can't remember when Epic was deployed at Sick Kids, but it's got to be at least 3 years now, right? 4 years, maybe 4 years now. And it's still like, what, right? In terms of understanding the protocols and getting everybody trained on it, it's tricky. So that's a good. But does anybody have any experiences to share with Alex? Alex, I think you stumped the panel. I love it. Anyway, just mindful of time, we have another question. Halima asks, if AI becomes more accurate than humans in every area of medicine, would it be unethical not to rely on it completely? Wow. That is an interesting question. Who wants to grab a hold of that one?
Obviously, yeah.
I don't know about obviously, but okay, Jeff, tell me.
I mean, isn't our job to make sure that we're providing the best possible care we can to patients? with whatever resources we have available. So if you had like if in your possession you had like I don't know, 100-year-old CT scanner and a modern CT scanner, would you ever purposely scan the patient on the 100-year-old CT scanner if you didn't have to? So it seems like the same thing. If it's better than we are, like why would you say let a human who's 96% good at reading a chest X-ray read a chest X-ray when an AI, which is 99% good at reading a chest X-ray, can read it instead? Now, whether or not they'll ever get to that point is a different story, but
Yeah.
I think if they are truly better than humans, then we have to deploy them.
Excellent.
Yes, even if they are not explainable, I agree.
Yeah, I can't explain my own brain either. I'm still allowed to read chest X-rays.
True.
It's a great question though. It is truly a great question, and I think there is room today as examples where that's not necessarily true, but I think in the future it would be. So an example of that is the constant, back and forth between traditional and modern medicine, right? So depending culturally, it is clear that there are more accurate and effective ways to diagnose or to treat. But in that culture, they wish to preserve the traditional medicine. And so I think that's a little bit of an example where you won't necessarily adopt the latest and greatest unless that's what you want. I think Jeff's right, frankly. I think it's going to, if AI is 100% accurate and we're not, then why wouldn't we? It's clear on that. But it is an interesting, taking into account the cultural and the cultural wishes, is an important factor. And we, Giancarlo, I'm sure can comment on that, and I'm sure Roberto can comment on that. That depending on the culture you're in, they will not necessarily, actually, generally they don't, just adopt modern medicine immediately and take that as the best, right? So it's always a challenge of integrating, traditional medicine and modern medicine to improve the overall, but respecting the culture. So I don't know if Giancarlo or Roberto wants to comment on that, but inevitably that's a reality, right?
Yeah, well, you explained it very perfect, Pascal. Well, with humans beings, you have to remember that people have to believe you. So at the end, we know that in modern medicine or traditional medicine, people is going to someone that knows about biology or about health, and they believe you. So what happens when everything that you has been growing up and all the thoughts and all the perspective and all the heritage, then someone appears for 1 hour conference, 2 hour presentation, and tell you that that's not the right answer or tells you that it's something different, probably as a human being you will not believe. So probably you will maintain the structure, the activities that you have. So that is so important to understand, and then to try to have kind of projects or activities in which you can combine or make a mix of all these areas. So at the end, people start to understand why are you doing that, and especially I will call that like key points of conjunction, like trying to have points in which traditional medicine and points in which modern medicine match, so that can be a bridge to get them. I will just give quick example. In some kind of indigenous communities, there was like ictericia about neonatal kids. So when you talk with the leaders of the community, said like, hey, you have to go to the river. So we were like, what? You know that you have to, for example, the recommendations is go to the mom is put your baby to the sun, and then if you need photo therapy or whatever. So, but we went a visit with them, and then we noticed that in the forest, maybe when there are their huts and their houses, there is not so much sun. So in the river, there is like a huge plains, and in that area probably there is more sun. So it seems like they are using that for obviously getting better. So that kind of bridge can make you say yeah, we are doing pretty much the same. We give this advice to our people, you give this advice to our people, and the end is the same concept. That makes you kind of feel kind of trust about these people, and then about this bridge you can start to give them different ideas and different concepts to get them. Just to give an example.
No, awesome. Awesome. Thank you. I think we're going to call this the last question, but we have a question from Mohammed. And what steps can be taken to mitigate the risk of model bias in AI healthcare applications, especially when training data may not represent all demographic groups equally? Who wants to tackle that one? So that's bias is a challenge. So who would like to take on that one? When you're training your data, how do you avoid bias? Or how can you avoid bias?
I'll start, I guess.
Please.
I mean, I think there's a number of approaches that can be taken. The first is, I wouldn't assume bias. We should measure bias and actually see. There can be a difference between data appearing bias and models that actually learn bias. So we published a paper a few years ago on how to measure the actual impact of these biases in the models and the fairness, and other groups have done this as well. So I certainly Google around and read those. And then once you've identified that there's bias in the model, then there are various fairness training strategies to try and encourage models. And they can be as simple as, let's say that you had 80 men in the data set and 20 women, you would upsample or downsample to make things equal, to far more advanced machine learning strategies that try and deal with it. But the first kind of identify and then pick your poison of your strategy sort of thing, and try and attack. Don't just say, oh, it's too hard to give up.
Thank you, sir. Anybody else comment? Okay. Well, on that note, I'm going to thank you all for attending. Excuse me, I'm just coughing at the end of the session. Excuse me. Okay. Thank you very much for joining. Thank you very much for the panel. Oh God. So sorry. It's been a long day of chatting. On that note, we're going to close the conference. If anybody has any questions, please feel free to put them in the chat, or email. Oh, I'm so sorry. Oof, I'm so sorry. Okay. Thanks for joining. Please put into the chat anything you would like to put in. Your questions, if you put them in now, we can send them out for email for answers. And I think that's it for housekeeping. Other than that, we'll send out an evaluation form. Well, please, I hope you'll participate. And then we'll follow that up with a certificate for all the attendees. So thank you. That's it. Thank you very much for joining.
Thank you so much. It was a great conference.
Thanks, everyone.
Thank you, Pascal. Thank you,
Yeah,
everyone.
thank you. Thank you for joining. You guys are amazing.
Pascal.
All right.
Bye bye. Pura vida.
Thanks.